Good morning, everyone. Okay, fine. Let us start. See, here it is heavy rain. If you have any issues, like if you have any interruptions in the internet, just make a WhatsApp call immediately. Okay, because we cannot give assurity for the signal. Okay, let's start. So today we are going to start. That is a beautiful subject. That's engineering mathematics, right? See, we can say without engineering mathematics, we cannot learn anything, right? Even you can go network analysis, entire electrical engineering, right? Anyway, we are going to learn electrical mathematics, right? That is electrical engineering mathematics. We should learn all the things in the electrical engineering point of view, right? As an electrical engineer, because application of mathematics, it's very vast, because this universe is existing with the mathematics only. Wherever you go, each and every places, at each and every iterations, each and every calculations, manipulations, programmings, right, in the day-to-day life, எல்லாமே வந்து maths தான் இல்லையா? See, the conclusion is what we have to learn. So in that point of view, if we have started learning the engineering mathematics, then we should see this universe. We should demonstrate all those things in the practical observations point of view. But let me quickly demonstrate the things. The thing is, we are going to learn all our engineering, that is engineering mathematics, in the electrical engineering point of view only. Because in electrical engineering itself, its application is vast, right? We all know, right? Whichever the subjects that we learn till now, all these subjects are only depending on mathematics. See, is there any calculation without any integration? Is there any calculation without differentiation? Is there any point without what I can say, if you take any signals or systems, right? நீங்கள் எங்கே போனாலும் சரி, மல்டிப்ளிகேஷன், டிஃபரன்ஷியேஷன், டிவிஷன், ரைட், வித்தவுட் மேத்தமெட்டிக்ஸ் நத்திங் இஸ் தேர் இன் திஸ் வேர்ல்ட், ரைட்? Yes. So which are all the topics that we are going to cover, right, in engineering mathematics? See, actually in our engineering mathematics syllabus, the first chapter that we are going to look at now, it's called linear algebra. People are calling it as matrices. And the second chapter, we are going to discuss about differential calculus and as well as vector calculus. And then we are going to discuss about what I can say, differential systems, right? That is the differential equations, ordinary differential equations, partial differential equations. We are going to discuss about them, and slightly side by side, I will tell you some applications already we learn in our electrical engineering itself. I told you not many places I will tell you these things in engineering mathematics. I will tell you these things in engineering mathematics. So we are in engineering mathematics now. So we should see where நம்ம என்னென்ன அப்ளிகேஷன்ஸ்லாம் பார்த்தோமோ அது எல்லாத்தோட ஆரிஜினும் இப்போ நம்ம பார்க்கணும், ரைட்? எஸ். So like that, in each and every subject, each and every chapter, while crossing the topics, I will let you know where we saw those things already and where we are going to use these things in engineering mathematics, sorry, in our engineering electrical applications especially, right? It's really very, very quite interesting subject, and it is usually scoring subject, because if you go up with the electrical machines and even electrical machines only, right, we should analyze the system, each and every part, why it is, why it is, why it is. That's very important. But that's very easy subject. Electrical machine, it's really very easy. But the thing is, in order to let that subject become easy, you should understand this subject properly. That's very important. Okay, fine. Next, what I would like to conclude, the second thing, after completing differential equations, we are going to discuss about complex variables. Soon I will let you know, right? Complex variables in the sense, see, separate topics are there are no big difference between them. அந்த ஒரு சாப்டரை கிராஸ் பண்ணும்போது அதோட அப்ளிகேஷன்ஸ் எங்க இருக்குன்றது நமக்கு தெரிஞ்சிடும், right? Fine. So after completing complex variables, immediately we are going to start numerical methods, right? And then we should talk about probability and statistics. We should see, right? This probability statistics வந்து நம்ம நிறைய விஷயம் கேள்விப்பட்டிருக்கோம், பட் அந்த விஷயத்தை வந்து நம்ம இது வரைக்கும் திங்க் பண்ணி பார்த்துருக்க மாட்டோம். I will let you know, right? So practically we will take all these things in the home itself. We will take the examples and we will see how probability that we are applying, how we are doing the statistics. Statistics in the sense of mathematics calculation should be required. I will let you know, right? So where people are using that things, okay? Blah blah things. Fine. And then we should talk about series, that's Fourier series. And then we should talk about the transform, like what I can say, Laplace transformation and Fourier transformation. At last we should talk about is the transformation. But hopefully we had completed the series and the transformations and signals in system with in-depth explanations. So I don't want to go up with that one once again, right? So we are neglecting series and the transforms because there are no new things that we are going to learn. Whichever the things that we learn in signals and system, that's its application. You can just go up with that, right? So what are the topics that we are going to cover? We are going to learn linear algebra. Second, we are going to discuss about differential calculus as well as vector calculus. And then we are going to talk about differential equations. And then we are going to talk about complex variables. And then we are going to discuss about numerical methods. And then we are going to discuss about probability and statistics. Okay? We will see all those things one by one, right? So first, let's take the chapter number 1. It's simply called linear algebra, right? Okay, fine. Now, what is the application of linear algebra? Where we are going to use it? It's very simple. Listen, I'm just standing in this position in front of you, right? Now, I would like to tilt my head, right, by an angle. But directly on the space, lighter tilt, correct? So tilting, namakku practical we have not noticed these things, right? So when I am, or otherwise we can simply take this hand, right? Now it's in the vertical position exactly. Now I am going to rotate. It means this is the new position of my hand. Do you agree? Yes. Now again I am tilting. Yes, that is one more new position. Again I am tilting, one more new position. Now I would like to get back. One more initial position. Again I would like to get back. One more initial position. So we are first I would like to travel in the forward direction, and then I would like to travel in the reverse direction. If you are traveling in the forward direction, then that is called a forward matrix. We are simply calling it as matrix. We are defining these terms in terms of matrix. When we are trying to get it back to the original position, we are calling it as inverse matrix. You might learn these things. A inverse equal to 1 by determinant of A into adjoint of A. We are using some simple formula in order to obtain the inverse matrix. Actually, what do you mean by inverse? Nothing is there. If I am traveling in the forward direction in the car, I would like to reverse the direction. First I am going from home to Ooty. From my home I would like to travel Ooty, right? So after reaching Ooty, after visiting all the places, I have to get back through in the same way which I have gone through, right? So if I would like to, right, on the same way return varinga appadina, I have to trace the path whichever the tabs that I had been followed initially, right? Again I have to trace them in order to reach my that is actual native place, right? So that is called inverse matrix. There are nothing to learn, right? Big things. You can take satellite. Satellite is running, right? நம்ம எர்த்ல இருந்து satellite வந்து வெளியில ரன் ஆயிட்டு இருக்கு, கரெக்ட்டா? See, it is being positioned, right? ஒரு கரெக்டான வெலாசிட்டில வந்து நம்ம satellite வந்து பொசிஷன் பண்ணனும். அப்ப நீங்க என்ன பண்ணனும்? We should measure the distance, right? Exact distance. அந்த நம்ம எர்த்ல இருந்து எவ்வளவு டிஸ்டன்ஸ் வந்து நம்ம satellite பொசிஷன் பண்ணா it will be in the equilibrium state. Do you know what do you mean by equilibrium state? அப்படினா மீனிங் என்ன அப்படினா satelliteல வந்து ஒரு opposition force வந்து கிரியேட் ஆகும். அந்த opposition force வந்து exactly equal to gravitational force. Gravitational force வந்து என்ன பண்ணும் அப்படினா usually see if I will keep some object here, இப்போ அத நான் விட்டா என்ன ஆகும்? Automatically it will fall down, right? Because gravitational force will pull that object. It's happening, right? In the same way, if you are letting some object to travel around the earth, that object is always being pulled by gravitational force. In order to oppose that gravitational force, we are providing one more opposition force in the satellite. Now what will happen? That opposition force will always be equal to the gravitational force, but they are opposing each other. Gravitational force satellite la create ஆகிற force ரெண்டு பேரும் opposite இருப்பாங்க, such that they are in the equilibrium state. அப்ப என்ன ஆகும் அப்படினா opposition force இது ஈக்குவலா இருக்கும்போது in resultant that object won't move, it won't travel towards gravity. Or second case, suppose நீங்க satellite ல create பண்ற force gravitational force ஓட அதிகமாக இருந்தது அப்படின்னா it will go away, it will leave our orbit and it will travel somewhere. It will happen. Suppose if the gravitational force will become greater than the value of satellite's port, automatically it will pull the satellite, it automatically your satellite will fall down on the earth. So what will be the conclusion here? In order to fix a position, right, that is called a vector, three-dimensional vector, right? Let us take that object or satellite. This is my earth, right? This is our earth, right? So in this, from this earth, I would like to fix this satellite at this position. Now I would like to let this satellite to rotate. இப்போ நான் என்ன பண்ண போறேன்னா ஒரு சேட்டலைட் நான் வந்து லான்ச் பண்ணியிருக்கேன். அந்த சேட்டலைட்டோட ஒர்க் என்ன அப்படின்னா இந்தியாவில் இருக்க அக்ரிகல்ச்சர்ஸ் வந்து நமக்கு வந்து இந்தியாவோட அக்ரிகல்ச்சர் எங்கெங்கெல்லாம் பார்க்குறாங்களோ அந்த ஏரியாவில் வந்து வாட்டரோட லெவல் வந்து எப்படி இருக்கு, வெதர் சுச்சுவேஷன் வந்து அப்படியே கண்டினியூ ஆகுமா இல்லை, ஐ வுட் லைக் டு நோ தி என்விரான்மெண்டல் சேஞ்சஸ், ரைட்? அண்ட் பேஸ்ட் ஆன் தட் ஐ வுட் லைக் டு மேக் சம் what I can say ஒரு graphical data வந்து எனக்கு தேவைப்படுது for a year, right? இந்தியாவோட agriculture data. For that I am launching a satellite. அப்போ நான் என்ன பண்ணுறேன்னா I would like to change the position of the satellite such that it will going to travel, it will going to roam all over the India, right? And it will going to trace all the agriculture portions and water level, எந்த இடத்துல water அதிகமாக இருக்கு கம்மியாக இருக்கு, everything it will going to graphically predict to us, right? In order to do that one, we should change the position of the satellite. Do you agree? Yes, that is called vector shifting. What do I mean? அது அப்படியே கிராஃப்ல நம்ம ரெப்ரசன்ட் பண்ணோம் அப்படின்னா that's very simple. Let me demonstrate mathematically. The thing is, initially I have a set of variables here. Guys, listen. I have a set of variable. Let me call it as 1, 2, 3. Let us call it as -1. Right? That is the initial position. For example, let me explain you. With this, I am considering one more person. That person value is, let us consider 1, 1. Such that this resultant matrix will going to be here. Let me call it as matrix A. Let me call it as vector variables x. Simply just understand, nothing is there in engineering mathematics, but just I would like to demonstrate few things, then we will slowly enter into the subject such that you will have some what I can say feel, right? Feel with our mathematics. It's not mathematics, it's real world, right? You have to understand. Let's see. When I am multiplying these two matrices, what will happen? The thing is, listen. The matrix multiplication. Usually நம்ம எப்படி மல்டிப்ளை பண்ணுவோம்? First row will be multiplied with a column, right? The thing is 1 into 1. Usually how we are doing matrix multiplication? 1 into 1 plus 2 into 1 will going to be projected here. In the second position, 3 into 1 exactly minus 1 into 1 is going to be minus 1, such that its new value 2 plus 1 is going to be 3. 3 minus 1 is going to be 2. What I have understood here, I have a vector, right? I have a vector. That vector is being projected in the xy axis. Let us understand, right? And that value is being simply considered as 3, 2. For an example, in the x axis I have that object value as 3. In the y axis I have that object value as 2, such that this joining point will going to give us 3, 2 point. This is the initial position of your satellite. Now I would like to change the position of the satellite. For that I am changing this variable now. What I am going to know, instead of keeping 1 and 1, I would like to keep 1 and 2. Shall we see? Let's see what happened. 1 into 1 plus 2 into 2 will become 4 plus 1 will give you 5. 3 into 1 minus 2 will give you 1. Such that the new position will become 5, 1. Right? So 5, 1 in the sense, I am considering this is x axis, we are considering 5. In the y axis, I am going to consider 1. Such that your position of the satellite is being tilted. Do you agree with me? Initially, I was fixing the satellite at this position. Now your satellite is being, right, shifted to this position. Do you agree with me? That things I have done with the help of a vector. Do you agree with me? Yes. This is called variable vector. We will see, right? So this is called, in matrix we are calling it as eigenvector, right? Such that we are tilting the position. Like that, let us take. இதே மாதிரி நம்ம என்ன பண்ணிக்கலாம்னா satellite position மூவ் பண்ணிக்கலாம். Now just coming back. இப்போ நான் head வந்து rotate பண்ணேன். Like இப்படி இருக்கா, I am rotating like this. It is tilting. This is the initial position. Now by providing some values for x and y axis, I am shifting. Slowly I am shifting. Now what happened? In my new position, I will have new x variable and a new y variable, such that my head is being fixed here. Again I am rotating. Again new x variable, new y variable, it will be fixed. So the conclusion is what? Wherever you go, there are nothing in this world without mathematics, right? So in that way we can bring out, this is for simplest understanding, I took 2 cross 2 matrix. Now you can raise the order of the matrix. You can consider thousands and thousands of people. You can shift them all from one point to another point. Wherever you go, you can go. You can select the question. See, for an example, in 3-dimensional, nowadays, you know, நம்ம 3-dimensional technology ல நம்ம அதிகமாக யூஸ் பண்ணிட்டு இருக்கிறது மேட்ரிக்ஸ் தான். Some of you might have watched that video. Matrix அப்படின்னு சொல்லிட்டு ஒரு ஹாலிவுட் மூவியே வந்திருக்கு, right? See, if you see that movie after watching, that is after completing these things, you might get some ideas. Actually, that practical demonstrations you may not get the feel exactly in the relationsலாம் நீங்க பார்க்க முடியாது. But in that matrix, that code conversions, they are doing some encoding, decoding, everything, right, under matrix only. That movie will, அந்த என்கிரிப்ஷன் வந்து நம்ம எவ்வளோ ஒரு சிஸ்டம்க்கு எவ்வளோ பேக்கப் வந்து நம்ம செக்யூரிட்டி கொடுக்க முடியுன்றது you can see that one, right? They will demonstrate. So you can visualize this, right? So what I would like to conclude, இப்போ ஒரு கேம் வந்து நம்ம டெவலப் பண்ணணும்னு வச்சுக்கோங்க. ஒரு கேம் அப்படின்னா இப்போ நீங்கள் 3Dலாம் நிறைய கேம்ஸ் வந்து இருக்கு இல்லையா? You can play ஒரு மொபைலில் வந்து drdo, some of you might be read that soon, right? And what I can say, some games needs for speed, right? Some car games will be there, like you can அதெல்லாம் நீங்க ப்ளே பண்ணும்போது என்னன்னா you can visualize நம்மளே அதுக்குள்ள இருக்க மாதிரி ஃபீல் ஆகும், right? The thing is, அது எப்படி நடக்குது, we are interrupting, right? அந்த மேட்ரிக்ஸ்ல வந்து என்ன ஆகும் அப்படின்னா ஒவ்வொரு பொசிஷன் வந்து மூவ் ஆகும்போது அந்த ஆப்ஜெக்ட் வந்து மூவ் பண்ண they are interconnecting, right? நம்மளோட ஹைஸோட இதை எடுத்து கூட அது கூட இன்டர்கனெக்ட் பண்ணி வச்சிருப்பாங்க. Like some many other things are there. Just imagine ஒரு 3D வேர்ல்டுக்குள்ள நம்ம இருக்கும்போது எப்படி இமேஜின் ஆகும். Many of you might have watched this movie, that is 2, right? That is Robot 2, right? You might have watched that video, right? 3D ல பாக்கும்போது நமக்கு எப்படி ஃபீல் ஆயிருக்கும், we are visualize, அது நமக்கு டைரக்டாவே நம்ம இதுல, that is called matrix, right? அதுல ஒரு ஆப்ஜெக்ட் வந்து ஒரு பாயிண்ட்ல இருந்து இன்னொரு பாயிண்ட்க்கு மூவ் பண்றாங்கல, that is 3-dimensional vector. அந்த 3-dimensional vector வந்து எப்படின்னா இட்ஸ் ரியலி வந்து என்னன்னா ரியலிஸ்டிக்கா இருக்கும். நம்ம ஸ்பேஸ்ல நடக்கிற ஒரு விஷயத்தை நம்ம அப்படியே என்ன பண்றோம், டிவில வந்து டெலிகிராம் பண்ணுறோம். that is we are watching, that's all, just we are watching the TV, right? So அப்ப என்ன ஆகும்னா ஒரு தியேட்டர்ல நீங்க அதை பாக்கும்போது you can observe that one, right? practically இந்த யூனிவர்ஸ்ல வந்து ஒரு பேர்ட் வந்து fly ஆகும்போது நம்ம எப்படி அதை அப்சர்வ் பண்ணுவோமோ, that object is projected in 3D with the help of matrix only, because we அங்க என்ன நம்ம இங்க ஒரு ஆப்ஜெக்ட் இங்க இருக்கு, இது இங்க இருந்து இங்க மூவ் ஆகுது அப்படினா we understood a vector is moving from one point to another point. இது அப்படியே நம்ம என்ன பண்றோம், சிஸ்டம்ல we are projecting, right, with the help of what I can say matrix, right? So you might get some friction, like you can take any objects, right, whichever the components that we are using nowadays in chromatography, what I can say 3D dimension mathematics, I mean encoding, decoding, ஒரு சிஸ்டம்க்கு வந்து நம்ம வந்து எவ்வளோ செக்யூரிட்டி வந்து கொடுக்கணும் அப்படிங்கறத டிசைட் பண்றது மேட்ரிக்ஸ் தான், right? Now you can take many examples, right? You can see its application of what I can say, there are millions and millions of applications are there in linear algebra, right? I hope something might be understandable by you all. Let us see some of the applications in our electrical engineering. See, in network analysis we have been seeing what I can say mesh analysis. You might have remember in mesh analysis or nodal analysis, நான் என்ன சொல்லிருந்தேன், நம்ம ப்ராப்ளம்ஸ் இப்போ when we are going up with more number of unknown variable, இப்போ ஒரு 2 variables மட்டும் வருதுன்னா normally you can directly solve. Like if I have an equation like this, v1 plus v2 is equal to 3, or if I have minus v1, I have one more equation, minus v1 2v2 equal to 5. இப்படி இருந்ததுன்னா suddenly your mind will have a strike. நான் உங்ககிட்ட என்ன சொல்றேன்னா just to find out the vector variables, right? eigen vectors v1 and v2 அப்படி நான் சொல்றேன். நீங்க என்ன பண்ணுவீங்க, this is eigen vectors, this one இங்க x1 x2 அப்படி நீங்க மேக்ஸ்ல போடுவீங்க, that is our eigen vectors, right? So simply you will solve இந்த ஈக்குவேஷன். see there, இப்போ அப்படியே நான் இத ப்ரொஜெக்ட் பண்ணி காட்டணுமா, see there, இது நம்ம எப்படி எழுதலாம், in matrix I have the coefficient of v1 is 1 and the coefficient of v2 is 1, coefficient of v1 is minus 1, coefficient of v2 is 2, such that I can project it v1 and v2 on the RHS. I have 3 5, so we can write 3 5. Is it visible? Yeah, that's visible, right? That is how we can project in the mathematics. See there, I have simple KVL equation here. Anyway, you can directly solve it for this system. In the matrix when equal to 3, 5 வரணும் அப்படினா what will be the value of v1 and v2? Now we have to fix it. இப்போ நம்ம என்ன பண்ண போறோம் அப்படினா, I have two set of equations, right? In order to obtain in the values when equal to 3, 5 வரணும் அப்படினா 3, 5 வரணும் அப்படினா what will be the corresponding value for v1 and v2? That is the question. I can directly solve it, right? So v1 இது ரெண்டுத்தையும் ஆட் பண்ணீங்க அப்படினா this is going to be 0, such that v2 plus 2v2 will become what? Let us take 3 times of v2 equal to 5 plus 3 will become 8, so we can find out the value of v2 is equal to 8 by 3. Now after finding the value of v2, இந்த v2 எடுத்துட்டு போய் ஏதாச்சும் ஒரு ஈக்குவேஷன்ல சப்ஸ்டிட்யூட் பண்ணீங்க அப்படினா that will give you the value of v1. So அப்ப நீங்க correspondent v1 v2 ஃபைண்ட் பண்ணிட்டு அந்த பொசிஷன், right, அந்த v1 ஓட v1 க்கும் v2 க்கும், right, இந்த v2 equal to 8 by 3 இது correspondent v1 ஒரு வேல்யூ கிடைக்கும் இல்லையா, அவங்க ரெண்டு பேருக்கும் correspondent உங்களுக்கு கிடைச்ச வேல்யூ தான் 3, 5. Suppose if you want to change the value, right, it might be a voltage drop across the load or it might be your source, right? If you want to append some other source, இப்போ நீங்க load parameter வந்து change பண்றீங்க, right? So if you are choosing some other value for v1 and v2, such that what will happen, you might be requested to pass some other value of voltage. So the conclusion is what? In order to shift, right? Up electrical engineering nodal analysis, right? So the conclusion is what? If I go up with the 2 variable, directly you can solve. If I am going with the 3 variables, do you have any direct method? No. When we are going up with the 3 variables or 4 variables, there is no standard methods in order to produce the answer for that. We are moving on to the matrix. So in matrix, you can find out the answer for 3 unknown variables. 3 unknown variable அப்படினா நான் system வந்து select பண்ணிருக்கேன் சார். அந்த சிஸ்டம்ல வந்து 3 voltage sources இருக்கு. I would like to know their values. And the voltage sources or values வந்து என்னவா இருந்தா corresponding systemல வந்து இந்த loads வந்து satisfy பண்ணும். Like that, I would like to know the loads value for the corresponding voltage. How much amount of loads that I can connect with our system. See, நம்ம எல்லா loads எடுத்து வந்து ஒரே ஒரு transformer கூட connect பண்ணிட முடியுமா? No. It's based on the demand. அதால அந்த transformerல எவ்வளவு current supply பண்ண முடியுமோ அவ்வளவு loads தான் நீங்க connect பண்ண முடியும். When your demand is increased, one more transformer, additional transformer parallelly connected. நீங்க அதை வாட்ச் பண்ணிருப்பீங்க. ஒரு சில ஏரியால பாத்தீங்கன்னா ஒரே டிரான்ஸ்ஃபார்மர்ல பக்கத்துல வந்து ஒரு பில்ட் மாதிரி கொடுத்து ஒரு பாக்ஸ் மாதிரி வச்சு அதுக்கு மேல என்ன பண்ணிருப்பாங்க, we are keeping one more ஓபன்ல வச்சுக்கலாம். நம்ம தான் டிரான்ஸ்ஃபார்மர் எங்கனாலும் போட்டுக்கலாம்ல, we can throw it at anywhere. That's the beauty of transformer. Maintenance is very less, right? அப்ப டிரான்ஸ்ஃபார்மர் வந்து நீங்க எங்கனாலும் பிளேஸ் பண்ணிக்கலாம். வச்சிட்டு அது பக்கத்துல வச்சிட்டு we are trying to supply the power. So coming to the conclusion. The conclusion is what? So like that, when we are going up with the many unknown variables, we can go up with the matrix that will simply give you the position, right? அது எந்த பொசிஷன்ல இருக்கு, அதோட correspondent eigen value எவ்வளவு. அது eigen value அப்படிங்கிறது ஒரு ஃபேக்டர். Like initially I will have a position of, நான் இப்ப 3,2 ல இருக்குன்னு வெச்சுக்கோங்க. இப்போ இதோட லெந்த் வந்து நீங்க இன்கிரீஸ் பண்ணிருக்கீங்க இல்லையா? இந்த லெந்த்ல இருந்து இந்த நியூ லெந்த்க்கு போதல்ல. Further நியூ லெந்த்க்கு போயிருக்கு அப்படினா we are increasing by a scaling factor. For an example, initially the length of this scale is, for an example, I will take 4. That is magnitude. இது நீங்க எப்படி எழுதுங்க, இது நம்ம எப்படி எழுதலாம்னா 3i plus 2j வெக்டர்னு எழுதலாம். இதோட magnitude எவ்வளோ, root of 3 square plus 3 square plus 2 square எழுதலாம். கரெக்ட்டா? 3 square னா 9, 2 square னா 4, such that root 13 will going to be the length of this vector. Agree with me? Yes, it is rectangular coordinate. You can project it in the what I can say polar coordinate with the magnitude and its corresponding phase angle from the origin. So the conclusion is what? After obtaining this one, if you want to increase the length, initially 4 la irukku, now if you want to make it as 8 4 வந்து நீங்க 8 ஆ மாத்தணும் அப்படினா you have to multiply by a factor of 2. That's going to be eigen vector, eigen value. So in this eigen vector, we are choosing some what I can say some coefficients. That coefficients will go into some values, some factors. That factors will going to increase the length of the vector. We can obtain some new position for a vector. So the conclusion is what here in mathematics, right? It's really quite interesting to understand. Like in electrical world, I said in mesh analysis also, while going up with more than 2 variables, we are going up with what? Grammar rule நீங்க ஏற்கனவே படிச்சிருப்பீங்க இல்லையா? அந்த ப்ரொசீஜர் யூஸ் பண்ணி we are trying to find out the current equation, current values, right? In case of mesh analysis, similarly graph theory, it's only depending on matrix. Full graph theory, anyway, that is not in our syllabus. I'm just telling like that, right? So graph theory, that in full graph theory we are going up with the matrix only, right? In free time you can watch graph theory in our playlist, right? It was already being uploaded in our YouTube. You can watch it, right? If you want to know about graph, right? Fine. Let's continue. So the conclusion is what? Similarly, if you take control system, in state space analysis, what we saw, we had been developed state model equations. What I have done there, I was going up with the what? Control, what I can say mathematics only. We saw how to calculate the level of transition matrix. Do you remember? Yes, right? So while calculating transition matrix state model equations in order to demonstrate the number of storage variables, right? And then we had been calculated controllability, we had been checked observability, whichever the things that we have gone through in state space, I had been analyzed all those things with the help of whom? Matrix. So its application is very vast. Similarly, you can go with the signals system, especially in Fourier series analysis, right? In order to expand the linear combination of harmonic series in terms of cosine and sinusoidal functions, there also your vector analysis will fall in place, right? It's vector, it's set of vector only. See there, 3i plus 2j, we can demonstrate it is, you can see there, for an example, I have a vector, right? I have a vector like this, right? Can you write it in terms of cos theta and sin theta? Why not? We have seen many applications, right? If I have a person like this, right, with the correspondent length is theta and its length is x. Can you project it into y-axis and x-axis? I can. See there, if you want to project it, this is going to be what? Adjacent, this is opposite. Opposite in the sense you have to project it in terms of sin theta. In adjacent, you have to project it in terms of cos theta. We all know these things. Yes or no? Yes. So that is, see there. So what is the conclusion? I have a simple vector. That simple vector can also be expressed in the linear expansion of cosine and sinusoidal functions. So in signals system also we can take what? Vector components. That is our linear algebra or matrices. So the conclusion is what? You can also take power system, right? In matrix we have seen admittance matrix, impedance matrix. Is there anything without matrix? No. I can project all those things in terms of matrix. We can define all those things in terms of matrix. So the finalized conclusion is here. There are no things in this world without matrix. Its application is very vast, right? Let's start our engineering mathematics now, right? Because after seeing these many applications, you might see you cannot directly, first you should learn the maths in the mathematics point of view, right? Let me conclude. After learning all these things, I told you control system la starting la nama edha pathi practical la pesala. I told you first to learn it in the mathematical point of view and then we will see the practical demonstration. And a control system learner, is there anything without control? No. Is there any components? No. Our system, our class is control system. But dynamic control system with some changing schedule, we are going up with the class, right? So, but there is control system only, na? We cannot take classes up to 2 o'clock or 3 o'clock. At the same time, I cannot start the class 2 earlier, like 5 o'clock or 4 o'clock, like that, right? So, there will be some restriction. There will be some restriction. Within that restriction, we are going up with the linear and the time invariant system. Like that, wherever you go, right? So, wherever you go, there are no things without mathematics, right? So, the conclusion is, first அந்த சப்ஜெக்ட்லாம் நீங்க எப்படி கத்துக்கிட்டீங்களோ அதுக்கப்புறம் we can compare it, right? Control system full கத்துக்கிட்டதுக்கு அப்புறம் we can demonstrate with the practical world. Yes sir, here we have a control component, here I have a control component, I can call this one as the control component. ஒரு சிக்னலை பார்க்கும்போது yes, I have seen these things in signals and system, right? Yes, the same thing I am observing in the practical world. After joining in some PSCs you will come to know the things, right? Yeah, fine. Let's start the first chapter. It's called linear algebra, right? I just given some of the applications for your understanding. I hope things are very clear to you all, right? Yes. Let us start. Let us see. The first one is we are going to see. இப்போ நம்ம மேட்ரிக்ஸ் வந்து டெவலப் பண்ணணும். மேத்தமெட்டிக்ஸ்ல we have to develop some matrix. I am repeating once again. First to learn all these things in the mathematical point of view. Don't directly enter for the applications here, because understanding the application it's not a big deal. Once you complete the engineering mathematics, then you will come to know automatically. அது ஒரு இடத்துல நீங்க படிக்கும்போது ஓகே இதோட அப்ளிகேஷன்ஸ் இங்க இருக்கு அப்படிங்கிறது. But the thing is first understanding the system is very important before analyzing it, where we are going to use it. Clear? Yes. Let's start. The first one we are going to look at now in linear algebra. First one is classification of matrices. That is which are the classification of matrix are there, right? எப்படி எல்லாம் நம்ம ஒரு matrix வந்து define பண்ணலாம், right? So matrix அப்படிங்கிறது a set of rows and columns, right? So let me define slowly. I will demonstrate all those things. It's really very easy subject. There are no analysis, right? Simply you have to learn the methods and you have to learn how to apply these tricks on your question paper such that you will get the answer. It's over, right? Yes. Let me demonstrate. The first thing is, first we all have to, anyway, I said classification of matrix, right? Before that, matrix நம்ம எப்படி represent பண்ண போறோம்? Right now what I told you, we are going to create some set of rows and columns. Rows in the sense horizontal lines, right? Horizontal lines are called rows, whereas vertical lines are called columns, right? Vertical lines are called columns. Let me call it as column C1, column C2, column C3. Like I can go up to n number of columns. Similarly, right? Similarly, you can go up to m number of rows, right? Let me define row number R1, row number R2, row number R3, like I can go up to row number Rm, m. Clear? Such that order of the matrix can be defined as number of rows into number of columns, where m denotes the total number of rows, n denotes the total number of columns. So the order of the matrix is going to be, that is going to be the order of your matrix. That is going to be the order of your matrix, right? Now, based on this order, based on the value of m and n, this matrix can be classified into two types. One is called rectangular matrix and another one is called square matrix. One is called rectangular matrix and second one is called square matrix, right? So second we are going to learn about square matrix. Let's see what do you mean by rectangular matrix. We all know rectangle in the sense it is the product of breadth into height. Do you agree? Yes. But in rectangular matrix, whether your breadth and height are equal or not, no. When I am looking for a rectangular box நம்ம எடுத்துக்கிட்டோம் அப்படின்னா இதோட length and height are not equal. For an example, if your height is h, then your length is l. If both are different, length or height are different இருந்தது அப்படின்னா that is called rectangle. Suppose if they are equal, then that is called square. Do you agree? Yes. Such that in case of rectangular matrix, the order, that is number of columns and number of rows are going to be not equal. Whereas in case of square matrix, right, in case of square matrix, the m and n are always equal, right? Yes, right. That is conclusion, right? So in rectangular matrix, what you are going to get? You are going to get a different length and a different height, right? Such that, let me define. So in case of rectangular matrix, we can simply consider some number of rows and some number of columns. And I can consider it can be defined as the order m cross n, that is the rectangular matrix. Whereas when I am looking for square matrix, in square matrix, in this case what I have done, I had been created 3 rows. Let us consider only 2 columns. I said both are not equal, right? Yes. Whereas in case of square matrix, the number of rows that we are going to consider are going to be always equal to number of columns. See that I am getting 2 columns and 2 rows such that m cross n equal to, it will be defined as n cross n. Why I am defining it as n cross n? Why? Because both are equal. Do you agree? Yes. So that is called square matrix. Let us slowly increase this silly classification, right? One second. So next, let me rub these things. So now I am going to introduce some variables. They are called what? Coefficients. If I am ஒரு வெக்டர் இருக்கு அப்படினா அந்த வெக்டர் வந்து நம்ம மேட்ரிக்ஸ்ல வந்து ப்ரொஜெக்ட் பண்ணும்போது, right, they are simply called as, we are calling them as coefficient, right? Let us see how to write this matrix, right? அதோட இன்னர்ல இருக்க ஆப்ஜெக்ட்ஸ் எல்லாம் எப்படி எழுதுறதுன்னு பார்க்கலாம், right? You can consider rectangular matrix as square matrix. For an example, let us take square matrix, right? Properties of a matrix. You can consider square or rectangular. Just I am introducing how I am going to define the variables that are lying inside the matrix. So inside the matrix, in the sense, the square matrix in the sense, number of rows and the number of columns are going to be equal, right? And how we are going to project the objects, right? The object is, for example, first let us consider A. Let me consider 3 variables. I am creating column number 1, column number 2, column number 3, row number 1. How many rows I may need? Number of columns and number of rows should be equal, such that I am again reflecting A. Again I am reflecting one more row, A. Exactly, all is correct. Now, first we have to define its order is row into column. First we will have to consider row and then we will have to consider column. Do you agree? Yes. So this is the first row. So it can be represented as A1 because first row. And this is the second row. It can be defined as A2. And this is the third row. It can be defined as A3. Do you agree? Yes. And this is the first column, so it can be defined as A1. This is the second column, it can be defined as A2. This is the third column, it can be defined as A3. Such that the matrix, that is the variables that are being projected here can be written as A11, A12, A13, A21, A22, A23, A31, A32, A33. Nothing is there. That variable position in matrix, how the way we are going to fix the variable, right? There are no things to understand. Okay, fine. So these are called what? Coefficients of your vector. For an example, project for this you might have 3 vector variables, right? With this, if you want to project the vectors, I can call them x1, x2, x3. Okay, if I am just writing like this, meaning this a11, a12, a13 are going to be the coefficients of this vector, eigenvector. Clear? That is what I would like to conclude. This is the coefficient of eigenvector. That is how we are representing them, right? So let us see the sum of other classifications. The next thing is, let me demonstrate all the classification of matrix one by one. What we saw, we learned 2 types of matrix. One is square matrix and another one is what? Rectangular matrix, right? Now, what we are going to do, the second thing is, now I am just making A11, right? A11 and I am just considering A22, let us consider A22, right? And I am just considering A33 are going to be equal, right? And of course I am considering they are equal to 1. I am considering all are equal to 1. They are called what? See there, wherever, if your rows and the column values are equal, if row value and the column value are equal, then that is called diagonal matrix. Then that is called a diagonal element, right? Then that is called a diagonal element. Then that is called a diagonal element, or that is called a principal diagonal. It's also called principal diagonal element, right? Principal diagonal element. Okay. Sorry. principal diagonal element. That's all. So that is how we are writing principal diagonal elements, right? So if all are equal, right, and I am representing rest of things, you see they are going to be equal, and the second thing is I am assuming rest of all people are going to be 0. Rest of all people are going to be 0. Rest of all people are going to be 0 in the sense, guys, did you notice one more thing? Let me write this in another way. Listen, இங்க நான் என்ன சொல்றேன்னா row ல வர values வந்து நான் I ல define பண்ண போறேன், columns ல வர values வந்து நான் J ல define பண்ண போறேன். Such that I am calling it as I dot J, right? So அப்ப நான் அதை ஜெனரலா எப்படி டிஃபைன் பண்ணலாம் அப்படினா I dot J அப்படி டிஃபைன் பண்ணலாம், right? So இந்த வேரியபிள்ஸ் வந்து நம்ம எப்படி டிஃபைன் பண்ணலாம், I dot J அப்படி டிஃபைன் பண்ணலாம், I, J. So this is, let me write IJ, 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 like that we can write IJ, 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 we can write IJ, IJ. Just we are giving some name. Example இந்த IJ எல்லாம் பார்த்தோம்னா நம்ம மைண்டுக்கு வந்து என்ன ஒரு மாதிரி குறை வச்சிருக்காங்க அந்த மாதிரி திங்ஸ் வரும். Nothing is there. Just அவங்க நேம்ஸ் அப்படி ரெப்ரசன்ட் பண்ணுவாங்க, right? Just see there. அப்ப நான் என்ன சொல்றேன்னா I value 1 J value 1, I value 1 J value 2, I value 1 J value 3, I value 2 J value 1, I value 2 J value 2. Like that we can define all the people, right? Generally we are calling it as IJ. Now here the conclusion is if I and J are equal, then we are talking about diagonal elements. Correct? See there. Where is your diagonal elements? This is called diagonal elements. I and J are equal in the sense we have 1 1 2 2 3 3. Where engage அந்த மாதிரி இருக்கா பாருங்க? No. So that is called diagonal elements. That elements is called diagonal elements. That is called diagonal elements. Similarly, rest of all people. Rest of all people na yaru? Rest of all people in the sense this person and this person are going to be called, these two people are combinedly called off diagonal elements. They are called off diagonal elements. Clear? I hope things are clear to you all, right? So this is called a diagonal and this is called off diagonal. இப்போ நான் என்ன டிஃபைன் பண்ணிருக்கேன், diagonal is going to be equal to 1. So இப்போ நான் என்ன சொல்ல வரேன் அப்படினா I ஓட வேல்யூ வந்து J க்கு ஈக்குவலா இருக்க எடுத்தலாம், we are keeping 1. If the value of I is not equal to J, then replace all values by 0. எங்கெங்கலாம் I and J ஈக்குவலா இல்லையோ அந்த வேல்யூவை நீங்க 0வா கன்சிடர் பண்ணுங்க. அப்படி கன்சிடர் பண்ணீங்கன்னா that matrix can be rewritten as first case, right? What I have done, if I replace all diagonal elements by 1 such that 1 1 1 and I am considering rest of all values are equal to 0, I said, right, rest of all values are going to be equal to 0, then that matrix is called unit matrix or identity matrix. That is called unit matrix or identity matrix. That is called identity matrix. That is the first matrix that we are defining from here. I hope things are clear, right? And I am talking about what? Square matrix only, right? So this is called identity matrix. Okay. Similarly, let me define rest of all values. Now there is, if I will multiply by a factor k, right? This is unit matrix, right? Let me demonstrate all those things one by one. Video is not clear, sir. Board is not clear. 7:52. Is it okay now? Someone said it's okay, sir. See, just adjust for 2 or 3 days. I said one more room we are separately building for this, right? That implementation is going on. Zoom, within 3 days or 4 days, we will shift that. That is completely digital room. There you don't have any issues, reflections and board clarity. You won't have any issues, right? I will solve all problems, so don't be panic. Just adjust for 2 to 3 days, okay? Yeah, fine. Let's go ahead. Next, so that is called unit matrix. Now, just to take that unit matrix, multiply it by a constant scalar factor k, such that what will happen? 1 0 0 0 1 0 0 0 1. Now I am just multiplying it by a factor, a scalar is called k, such that this unit matrix can be remodified as, it can be written as k 0 0 0 k 0 0 0 k. What I have understood here, each and every element is going to be multiplied by the factor of k. But the luckiest thing is many people are 0 here. 0 into k, 0 only. 0 into k, 0, 0 into k, 0, 1 into k, 1 k, 1 into k, k, 1 into k, k, like that. So this matrix is called scalar matrix. This matrix is called scalar matrix. This matrix is called scalar matrix. Clear? So what is the conclusion here? Just I took unit matrix, right? So in scalar matrix, what we have understood, in scalar matrix, all these values are going to be equal only. But see that they might be equal to 1, or you can also consider some other value. See, who knows, the value of k might be 1, or it might be 2, or it might be 3, 4, 5, 6, 7, 8. Any values can be considered in the diagonal. But all these diagonal values are going to be equal only, but they are not. They may or may not be equal to 1. So, your scalar matrix might be called as unit matrix. Yeah, when the value of k equal to 1, it is equal to unit matrix. Otherwise, it is simply called, if the value of k equal to 2 or some other variable, then it is called what? Scalar. Scalar in the sense, unit matrix can be multiplied by a scalar. Clear? That's simply called scalar matrix. Now, let us talk about from here. Suppose in the same matrix, I don't have equal values here, right? I have some other values. For example, I have k1, 0, 0, 0, k2, 0, 0, 0, k3. Then this is simply called diagonal matrix. See, I have only values in the diagonal, correct? Only diagonal principles are existing here. Rest of people are 0. It means this matrix is called what? Diagonal matrix. This is called diagonal matrix. So what I have understood, in case of diagonal matrix, they may or may not be equal to, they may or may not be equal. They might be equal to each other, or they may not be. The thing is what? Diagonal in the sense, in the given matrix, variables will exist only in the diagonal. Principal diagonal elements only will be not equal to 0. Rest of all values are going to be 0. Clear? Yes. Diagonal what value exists? No. Are different out. I don't know that one. You can give 10, 11, 12, or you can give 100,000, or you can give 102. Something you can consider. But variables will exist only in the diagonal. Rest of values are going to be 0. Such matrix is called diagonal matrix. Clear? I hope things are very clear to all. So what is the difference? First we learn about unit matrix. Yes. Second, we learn about scalar matrix. Of course, there might be identity between them. When k equal to 1, then scalar matrix will be equal to unit matrix. In case of diagonal matrix, your diagonal value, see there, your scalar matrix can also be considered as diagonal matrix. But diagonal matrix cannot be considered as scalar matrix. When, see, that case true, if k1, k2, k3 all are equal, then only this matrix will be called as scalar matrix, because in scalar matrix all the diagonals are equal. If k1, k2, k3 equal, then that matrix is called what? Scalar matrix. Then k1, k2, k3 equal to 1, then that is called unit matrix. Otherwise you can segregate them. This is called a scalar, this is called a diagonal, this is called unit matrix, like that. Okay, I hope things are very clear. Let's see, let us moving on to the next type of classification. Let me rub this one. Yeah. If I rub, let us take some other properties, right? Okay, I hope now you all have understand how to represent the matrix. Let us take, right, once again, let me take the square matrix only, right? Let us consider, I took 3 variables, right? A. Let us take A only, right? But first I have to talk about row. This is the first row, yes. This is the second row, yes. This is the third row. And this is the first column, and this is the second column, yes, and this is the third column. Do you agree with me? Yes? Yes, that is called a square matrix. But now I am going to do few more things. I am just assuming that the value of A21 and the value of A32 and the value of A31 are going to be equal to 0. Such that this matrix can be rewritten as, right, such that if I apply these things into the matrix, this matrix can be rewritten as A11 will exist, A12 will exist, A13 also will exist, right? This is going to be 0 now, right? So this is going to be 0 because A21 is 0, and then A22 will exist, of course, A23 will exist, of course, right? And this is going to be 0, yes, this is going to be 0, and this is also going to be 0, A33 will exist. Now, if you notice this matrix carefully, right, guys, listen, this is called diagonal. Right? This is called diagonal. Now, apart from this diagonal, I have, you correct observe, see there, I will join these two people, and I will join these two people, and I will join these two people. Similarly, I am going to join these two person, I am going to join these two person, I am going to join these two person. It is looking like a triangle. Do you agree with me? Yes. It is looking like a triangle. Similarly, this is also looking like a triangle. This is also looking like a triangular matrix. Now I can call it as in the diagonal that is called upper triangle, if elements are existing below to the diagonal principal, then there is called a lower triangle. Do you agree? This triangle will exist what? This is called a lower triangle. Why? Because this triangle is existing below to the principal diagonal. Whereas these people are existing above to the diagonal, that is called what? Upper triangle, and this is called lower triangle. Now the conclusion is, if you notice this matrix from this, right? When I am going from here to here, I understood one thing. The thing is, all the lower triangular values are going to be 0 here. See there, carefully observe this one. All the lower triangular matrix are going to be 0. Yes. Only upper triangular will exist. Above the principal, only upper triangular will exist, but lower values are going to be 0. These type of matrix are called upper triangular matrix. Upper triangular matrix. Why I am putting this name? Why? Because I understood there are two type of triangle is being existed here, but one triangle is completely 0 now. So I can happily say in this matrix only upper triangular matrix is being existed. So I am naming this matrix as upper triangular matrix. Is there any mistake? No. In the same way, let me demonstrate, right? So this is the one model. Second case, this is case number 1. I am injecting. Case number 2. Let me inject A12, A13, A23 as equal to 0, such that same matrix can be rewritten as, right? So let me write like this. Same matrix can be written as, let's start from A11 will exist, A12 0, A13 0, A21 will exist, A22 will exist, A23 0, such that A31 will exist, A32 will exist, A33 will exist, right? Now, if you notice this matrix carefully, above principal diagonal, all the values of, right, upper triangle matrix are going to be 0. Up in the matrix, lower triangle button, yes. So this matrix can be called as lower triangular matrix, right? So I can name this one as the lower triangular matrix. Clear? I hope so. We are looking for other type of triangular matrix, that is called upper triangle matrix, and another is called lower triangle matrix. I hope things are very clear to you all. Yes, right? Let us see all those things, right? Some other type of classification of our matrix, right? So let me rub this one, right? Let us move, right? So let us move to the other type of classification, right? Let me rub these things now. Yeah. Yes. Okay. Now we are going to see, based on the properties, some other type of matrix are there, right? Yes, we have been observed unity matrix is over, diagonal matrix is a, scalar matrix is a, triangular matrix will be there. In triangular we have upper triangle matrix will be there, lower triangular will be there. Like we have been observed, square matrix will be there. What I can say, non-square matrix will be there, right? So let us see, next type of matrix is called singular matrix and non-singular matrix, right? So what do you mean by singular and non-singular, right? So let us see some of the properties. Once again, singular non-singular matrix will be the classification of square matrix. Under square only we are going to consider singular and non-singular matrix. First, we have to select some square matrix. Let us see. We have to select some square matrix. In this square, right? Square matrix in the sense, shall we take 2 cross 2? Or we can consider 3 cross 3 also, no problem. Square na meaning enna? See there, square in the sense, first of all, if number of rows are 1, then number of columns also should be 1. If number of rows are 2, then columns also should be 2. If number of rows are 3, then columns also 3. If number of rows are 4, then columns also 4. If number of rows are 5, then columns also 5. Such that this all people are calling it as square matrix only. You can consider any one for your example, right? You can go with the 2, 2, 3, 3, 4, 4, etc. right? Anyway, let's go ahead with the 3 cross 3 matrix. Let's define, right? Singular and non-singular matrix. Now this is going to be first row, yes. Second row, yes. Third row, yes. First column, yes. Second column, yes. Third column, exactly. That's all. Do you agree? Yes. Now what do I mean by, I said singular matrix and non-singular matrix, right? First of all, singular matrix in the sense, you have to find the determinant for this matrix. Anyway, the next topic immediately we are going to talk about the determinant only. First, there is a term is called determinant. First you should try to understand. Let me name this total matrix as A. I am just calling this matrix as A. In the matrix வந்து நான் ஒரு பேர் வைக்கிறேன், அந்த பேர் வந்து A ன்னு சொல்றேன், right? அப்ப இந்த whole matrix if you are finding the determinant of the matrix can be represented by modulus, right? If you find any terms in matrix like this, it means they are talking about determinant of that person, right? So in case of singular matrix, determinant of the matrix is going to be equal to 0. right? If I am finding the determinant of any matrix, if the determinant will be equal to 0, then that is called a singular matrix. Then what do I mean by non-singular matrix? What do I mean by non-singular matrix? Slowly I will grab all those things. First register. Again, you will come to know it. That will become very easy later, right? So non-singular matrix in the sense, we should talk about determinant of A, but non-singular in the sense, determinant will become not equal to 0. Clear? Yes. So that is called what? Singular and non-singular matrix, right? So let us moving on to the next type of classification. Yes. Let us talk about null matrix, right? So let me rub this one, right? So next we are going to talk about null matrix, right? So what do we mean by null matrix? Null matrix. Null matrix in the sense, you can select a 2 cross 2, 3 cross 3, 4 cross 4 square matrix only, right? So if you are going up with the what I can say 3 cross 3 matrix, then what I mean by null? Null na onnume illa. அப்படிதானே? null na ஒண்ணுல தான் அர்த்தம். அப்ப உள்ள ஒண்ணுமே இருக்காதுன்னு அர்த்தம். Information that they are going to carry in this matrix are going to be 0. That is called null matrix, right? So what will be the determinant? Automatically, the determinant of the null matrix will always be equal to 0 only. Why? Because see that all the values are going to be 0, right? So rank of, let me call, this one is matrix A. Rank of null matrix will always be 0. We will see. Immediately after completing determinant, I am going to talk about rank of the matrix only. This is the representation of the rank of the matrix, right? So this row denotes rank of the matrix, right? You might know, that is, I don't know, you all don't know about the rank of the matrix at all, but some frictions will be there. Already you will learn these things, right? Your faculties will taught these things in engineering mathematics, right? In our engineering curriculum. So some frictions will be there, no? That's enough for me. I will trigger it out, right? So this is rank representation. Rank of the matrix is going to be 0. Similarly, determinant also going to be 0 when we are looking for null matrix, because null in the sense there is no information. Clear? Yes. Let us look about, that is, let us talk about next type of matrix. Yeah, that's called symmetric and asymmetric, right? So skew symmetric. Let me call this skew symmetric, right? Yeah. Let's talk about first symmetric matrix, right? So next I am figuring out, that is called symmetric matrix. The next type of classification is simply called symmetric matrix. What do you mean by symmetric matrix? Symmetric matrix in the sense, for example, I have a matrix A, right? It was being defined like this, right? Like that matrix were given as 1 1 1 1, right? It is given like this. It is given like this, or we can take like this 1 2. Okay, best example, let's go ahead with 1 1, right? So this is called symmetric matrix. Now I would like to take transpose for this matrix. What do you mean by transpose? Transposition அப்படினா மீனிங் என்னங்க? Transposeனா மீனிங் என்ன அப்படினா, நீங்க வந்து ஃபார் எக்ஸாம்பிள் இப்போ நான் வெர்டிகலா நின்னுட்டு இருக்கேன் அப்படினா நான் அப்படியே ஹரிசாண்டலா நிக்கணும், right? So horizontal means we are calling it as lying, right? In human, for human being we are calling it as lying, right? The thing is, ஒரு பஸ் வந்து நான் என்ன பண்ணிட்டு இருக்கேன் அப்படினா, ஒரு பஸ் ஹரிசாண்டலா போயிட்டு இருக்கு, அதை பிடிச்சு நான் வந்து வெர்டிகலா நிக்க வைக்கிறேன், right? So that is called transposition. We are changing the position exactly 90 degree வந்து நீங்க அந்த பொசிஷன் வந்து மாத்தணும். ஒரு பஸ் வந்து ஹரிசாண்டலா போயிட்டு இருக்கா, அப்படியே பிடிச்சு நிறுத்தி நீங்க வெர்டிகலா மாத்தணும். A big train ஹரிசாண்டலா இருக்காது, அப்படியே பிடிச்சு நீங்க வெர்டிகலா நிக்க வைக்கணும், right? அப்படில ஒரு வெர்டிகலா இருக்க ட்ரெயினை நீங்க திரும்ப ஹரிசாண்டலா நிக்க வைக்கணும், right? So that is called what? Transposition. What do I mean? Vertical will become horizontal, horizontal will become vertical. It means rows are will become columns, columns are become rows. That is called transposition. Clear? So here vertical become horizontal, horizontal will become vertical in the sense, number matrix la horizontal na yaru rows, vertical na columns. Avanga position maathanum, avladha, right? So here let me call it as row 1, let us call it as row 2. This is going to be column 1, this is going to be column 2. Do you agree with me? Yes. So this is column 1, column 2, this is row 1, row 2. Shall we change them? Yes. So if I am looking for A transpose, I will write the answer at this point, sorry, at this position. The thing is, if this row, in the row வந்து நீங்க காலமா மாத்தணும் அப்படினா, இங்க இருக்கத நீங்க என்ன பண்ணனும், அப்படியே இப்படி பில்ட் பண்ணனும், மாத்தி எழுதணும். இந்த ஃபர்ஸ்ட் ரோவை ஃபர்ஸ்ட் காலமா நீங்க மாத்தணும், ரைட்? ஃபர்ஸ்ட் காலம் எடுத்து இந்த ரோவோட வேல்யூ எழுதுனீங்கன்னா it will become 1 1. அதே மாதிரி செகண்ட் ரோவை செகண்ட் காலமா நீங்க மாத்தணும். செகண்ட் ரோல வேல்யூ என்ன இருக்கு? 1 1. இத அப்படியே காலம் எடுத்து எழுதுங்க, it will become 1 1. Clear? Are you getting me? I am not going to do any big things here. அப்படியே இந்த ஃபர்ஸ்ட் ரோல இருக்க வேல்யூவை ஃபர்ஸ்ட் காலம்ல மாத்தி எழுதுங்க, செகண்ட் ரோல இருக்க வேல்யூவை செகண்ட் காலமா மாத்திடுங்க, அவ்வளவுதான், முடிஞ்சு. Clear? That is going to be, that is called transposition. After doing the transposition, observe the property of matrix A and the A transpose. Transposition பண்ணதுக்கு அப்புறம் ஏதாவது changes வந்திருக்கா? No. Whichever the properties that I have been observed in the basic matrix when I was going up with the A, same properties I am observing after doing the transposition. So the conclusion is what? This type of, in this matrix, matrix A will become equal to the value of A transpose is simply called symmetric matrix. Is simply called symmetric matrix. See, it's nothing but even under odd property of a signals. Signals system நம்ம ஏற்கனவே படிச்சாச்சு இல்லையா? ஈவன் சிக்னல்ஸ் ஆட் சிக்னல் ப்ராப்பர்ட்டிஸ் நம்ம ஏற்கனவே படிச்சிருக்கோம். ஈவன் சிக்னல்னா என்ன? ரெண்டு ப்ராப்பர்ட்டி ஈக்குவலா இருக்கும். x and minus x are equal, right? That is x of t and x of minus t are equal. Odd symmetric னா meaning என்ன? x of t equal to minus x of t. Like that we are facing something, right? So here in matrix we are defining like this. Clear? So that is called a symmetric matrix. Now let us talk about second person. I said the next type of classification is called skew symmetric matrix, right? So let me call the second person is called what? Skew symmetric matrix. Skew symmetric matrix. Okay, let us see, let us talk about skew symmetric matrix, right? So okay, shall I write this one? That's better because I can write them freely, right? If I have space here. Yeah, let's go ahead. I would like to talk about skew symmetric matrix, right? Let us talk about skew symmetric matrix. Okay, let us talk about skew symmetric matrix. Fine, right? Now when we are talking about skew symmetric matrix, right, what do I mean by skew symmetric? It means first let us take some matrix for example, right? What shall we consider? Let us consider 0 0. Let me consider 2 minus 2 here, right? Let us consider 2 minus 2. Such that what happens? Let's see. I would like to take the value of transposition. That is, I would like to find the transposition matrix. Can you please do it for me? Yes. So if you என்ன பண்றீங்க அப்படினா திரும்ப இத நீங்க transposition பண்ணீங்கன்னா first row will become first column such that it will become 0 2. Second row will become second column. இது அப்படியே நீங்க இப்படி டில் பண்ணீங்க அப்படினா it will become minus 2 0. What we have understood here, the thing is, இப்போ நான் என்ன சொல்றேன் அப்படினா இப்போ இந்த மேட்ரிக்ஸ் எடுத்துக்கோங்க. இந்த மேட்ரிக்ஸ் எடுத்துக்கிட்டா இந்த மேட்ரிக்ஸை -1 அப்படிங்கற ஸ்கேலிங் ஃபேக்டரால மல்டிப்ளை பண்ணுங்க. இத -1 ஆல மல்டிப்ளை பண்ணீங்க அப்படினா it will going to be 0 into -1 will become 0. 2 into -1 will become -2. -2 into -1 will become +2. 0 into -1 will become 0 only. What is the conclusion here? I understood, but is A transpose will become equal to -A. Or I can also reverse this property. A is equal to minus A transpose. Do you agree? Yes, you have to agree with me. That is called what? Transposition matrix, right? So sorry, skew symmetric matrix. Skew symmetric in the sense A will become what? That is A transpose will become equal to minus A, or I can say A is equal to minus A transpose. Such if any matrix which satisfies this condition, that matrix is simply called skew symmetric matrix. Right, that matrix is simply called skew symmetric matrix, right? Now the conclusion is, if you are finding the determinant for this skew symmetric matrix, determinant of, yes, I tell you soon after completing the classification, immediately I am going to talk about determinant only, then only we are going to talk about rank of the matrix. So I will let you know about the determinant at all. Idoda determinant just to find pannunga. If you are finding the determinant for this matrix, if you are trying to observe the determinant for this matrix, let's see what about the determinant. The determinant நம்ம எப்படி find பண்ணுவோம் அப்படினா, that is the product of diagonal 0 into 0 minus product of off diagonal in the sense 2 into -2, that is going to be -4, such that 0 into, that is 0 minus of -4 will give you +4. Clear? That is going to be the determinant of the matrix. Clear? I hope things are very clear to all. So if you notice these things carefully, in the 2 4 அப்படிங்கறத can I write like this? Shall I write 2 square? Yes. So the conclusion is determinant of a skew symmetric matrix will always be a perfect square number. Is there any mistake in my conclusion? perfect square number அப்படினா it might be இங்க 4 வந்திருக்கா, நீங்க வேற ஏதாச்சும் ஒரு சிஸ்டம் எடுத்தீங்கன்னா might 9 வரலாம், இல்ல 16 வரலாம், இல்ல 25 வரலாம், இல்ல 36 வரலாம், இல்ல what I can say 6 times 36 are 7 or 49 வரலாம், 64 வரலாம், 81 வரலாம். அவங்களாம் யாரு? 9 ஸ்கொயர், 8 ஸ்கொயர், 6 ஸ்கொயர், 5 ஸ்கொயர், 11 ஸ்கொயர், 12 ஸ்கொயர், அந்த மாதிரி it will be a complete perfect square number, right? So the conclusion is determinant of a skew symmetric matrix will always be a perfect square number when the order of the matrix will be even. The next statement is when the order of the matrix will be even. Here அப்படியே எழுதிக்கோங்க, right? So the determinant of a skew symmetric matrix will be a perfect square when the order of the matrix will going to be an even number. அது என்ன order of the even இருக்கணும்? Even அப்படினா either it might be 2 cross 2, or it might be 4 cross 4, or it might be 6 cross 6, or it might be 8 cross 8. Like that you have to go with the even number of order. Sir, if you are going with the odd number, then what will happen? If you are going with the odd number, கீழே எழுதிக்கோங்க. By solving the problems you will come to know, right? Suppose if the order of the matrix is in odd, right? If order of the odd number ல இருக்குது அப்படினா, then the determinant of a skew symmetric matrix will be equal to 0. Determinant of a skew symmetric matrix will be equal to 0, right? See, let me rub this one, right? Slowly you will come to know, right? Exit, right? 1 second, right? What I would like to conclude here, clear algebra, right? In case of skew symmetric matrix, I said determinant of the matrix, right? In skew symmetric, determinant of the matrix will be a perfect square, right? In bracket I can say when we have even number of order like 2 cross 2, 4 cross 4, 6 cross 6, etc. And this determinant will be equal to 0, right? When the order of the matrix will become 1 cross 1, 3 cross 3, right? I am going with 5 cross 5, like that. If I go, it will become 0. நீங்க clear notice பண்ணி பாத்தீங்களா? skew symmetric matrixல diagonal values வந்து எப்பவுமே 0 ல தான் இருக்கும். diagonal 2 cross 2 னா இங்க 0 0 தான் இருக்கும். Half diagonal values இருக்கும். But in diagonal your values are always 0, right? Completely 0. If you notice this one, in skew symmetric matrices, any order 1 cross 1, 2 cross 2, 3 cross 3, 4 cross 4, if you observe the diagonal, that is always will be equal to 0. That is one more property, right, of your skew symmetric matrix, right? Apart from that, some other type of classifications will be there. Some people are calling it as idempotent matrix will be there. I don't want to go to that things at all, right? Okay, let's start with this, right? So this much of classifications are more than sufficient, right, in order to solve the problems, right? So let us face, okay, these are all the classification of the matrix. Now what we need to do, immediately I said after completing the classification, I said we are going to start the second phase of our linear algebra, that is called determinant of the matrix, right? Now let's see how I am going to determine the determinant of the matrix, right? So let me rub this one. Let's see how I am going to find out the determinant of the matrix, right? So let us rub this one. Yes, let us rub this one. Now I will teach you what do you mean by what do you mean by determinant and how we are going to find out the determinant of the matrix, right? So let us take some 2 cross 2 matrix. First of all, you have to understand determinant அப்படிங்கிறது யாருக்கு நம்ம ஃபைண்ட் பண்ண போறோம் and what is the purpose of this determinant, right? சிம்பிளா நம்ம சொல்லணும் அப்படினா ஒரு மேட்ரிக்ஸ்ல இருந்து நீங்க determinant ஃபைண்ட் பண்ணும்போது it will completely give you the property of the characteristics of that person, right? So from this determinant only, from the determinant of the matrix only, we are going to derive the characteristic equation. From the characteristic equation only, we are going to find out the eigenvalue or characteristic root, or it is called latent root, or it is called proper value. I will tell you, right? And the eigenvalue அப்படிங்கற term வந்து நிறைய பேர் இருக்கு. That is also called characteristic root, that is also called latent root, that is also called proper value. So with the help of that property, with the help of that eigenvalue, you know that eigenvalue is simply called poles. That is simply called poles. Poles னோட மைண்ட்ல என்ன வருது? Control system. Control systemல poles ஓட property என்ன? With the help of poles we can identify stability of the system. என்ன stability? Whether the given system is stable or unstable, or it is marginally stable, or where it is located, its transient property, steady state property, blah 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 things, everything can be understandable. So indirectly we are talking about the practical observations only, right? Fine. So from the help of determinant, that is what we are going to do. Do you remember? Same determinant, right? I was using in control system state space analysis. I said stability of the system can be defined in terms of characteristic equation. Characteristic equation is nothing but determinant of A. Just revise your notes. அங்க நம்ம என்ன பண்ணிருக்கோம், determinant of A க்கு பதிலா si minus A determinant equal to 0 அப்படி நான் போட்டுருவேன். Right? So what is the conclusion here? With the help of this person, we are going to find out the stability of a system. Clear? Yes. Shall we start? Yes. Let's start our journey with the determinant of the matrix. Right? It's quite interesting actually. In mathematics, nothing is there, just a friction. You have to listen, you have to solve the problem, right? You won't like your questions never let you push you to think a lot. If you remember the concepts, you will get the answer. It's over. Clear? Yes. Okay, let's start with the second phase of our linear algebra, that is called determinant. Right? So next we are going to talk about determinant of the matrix. That can be simply defined as, right? Determinant will be represented by modulus A. Anyway, I am going to use the standard reference as A only. A denotes the matrix, right? And we are going to take mod for that. That is simply called determinant, right? And the first thing is, basically, while finding the determinant, we saw there are two types of matrix. One is called square matrix, and another one is called non-square matrix, or these are rectangular matrix, right? So these are rectangular matrix, right? These are rectangular matrix. Now, determinant can be applicable only for square matrix. Complete determinant it's only applicable for, right? So it is only applicable for square matrix. Whereas when we are looking for rectangular, you can find out the determinant only for submatrix. For submatrix, you can find out the determinant. I am repeating once again. ஒரு ஸ்கொயர் மேட்ரிக்ஸ் கொடுத்துருக்காங்க அப்படின்னா அந்த ஸ்கொயர் மேட்ரிக்ஸ்ல இருக்க கம்ப்ளீட் மேட்ரிக்ஸ்க்கு நீங்க டிட்டர்மினன்ட் ஃபைண்ட் பண்ணலாம். ஃபார் எக்ஸாம்பிள் ஐ ஹேவ் 2 2 3 4 இந்த மாதிரி இருக்குன்னு வெச்சுக்கோங்க. இப்போ இது நான் டிட்டர்மினன்ட் கேட்டேன் அப்படின்னா this is called ஸ்கொயர் மேட்ரிக்ஸ். அப்ப நீங்க என்ன பண்ணுவீங்க, simply you are trying to this is, let me call it as matrix A. If you want to know the value of determinant of this matrix, simply what will you do? Find the product of the diagonal, that is 2 cross 4 8, minus product of half diagonal will give you 6, such that it is going to be 2, such that you will be able to find out the square for, that is complete determinant for the square matrix. Now when I am looking for non-singular matrix, for example I have a matrix like this 1 2 1 3 1 through to 1, something like this I have. Can you find out the determinant for this directly? No. Complete determinant cannot be possible, but you can find out the determinant for subsquare matrix. இதுக்கு மட்டும் நீங்க matrix determinant find பண்ணலாம்ல? Of course, you can also find the determinant only for these people. You can also find out the determinant for this person, because in rectangular கூட நீங்க என்ன பண்ணலாம் அப்படினா we can create subsquare அப்படினா we can create the square inside the rectangular boxes. அப்ப நீங்க ஒரு ஸ்கொயரை கிரியேட் பண்ணிட்டு அந்த ஸ்கொயருக்குள்ள you can find out the determinant, but complete determinant cannot be possible when we are looking for rectangular matrix. I hope things are very clear to you all, right? Let's see how I am going to find out the determinant of any matrix, right? For 2 cross 2 matrix you can simply find, right? So anyway, let me rub these things. Let me demonstrate from the beginning. Let's go ahead from 2 cross 2 and then I will take 3 cross 3. Slowly I will deploy all these things such that you will be able to get the clear idea to determine the determinant of any matrix. Okay, fine. So the thing is, when I am looking for 2 cross 2 matrix and it has the variable one second, A, B, C, D. I have some 4 variables. Okay, yes. Now here, if you want to find out the determinant of the 2 cross 2 matrix, let us demonstrate. What I have to do, it is the product of diagonal, right? The statement is what? Product of diagonal elements minus product of off diagonal, right? So product of off diagonal, that is the product of off diagonal elements. I hope things are clear to you all, right? Let's see, that is product of diagonal minus product of off diagonal. Now what will be the product of diagonal? Diagonal in the sense that is A cross B, right? So let's say that is A cross B, that is the product of diagonal, minus product of off diagonal is going to be B cross C. Product of off diagonal is going to be B cross C, such that that is going to be determinant of the matrix. Clear? So that is how we are finding determinant of a 2 cross 2 matrix. Now from this, right, I would like to explain you few more things. For example, if you want to obtain the maximum determinant value from here, right? So for example, if you want to know the determinant, maximum determinant, right? இப்போ இதுல maximum determinant வந்து உங்களுக்கு வேணும் அப்படினா what will you do? Usually whenever we are looking for maximum value we need to do differentiation. We need to do differentiation, that is mandatory, right? So you have to take the action with respect to some variable that will be given commonly for both of these cases, right? So that's a common variable that கொடுத்திருப்பாங்க, right? Anyway here I did not given that common variable, but I can complete, that is I can derive these things directly. நான் என்ன சொல்றேன்னா, if you are looking for maximum for this without doing differentiation, I would like to tell you something. இப்போ நான் என்ன சொல்றேன்னா, see there இங்க a into d அப்படிங்கற இடத்துல நான் 10 அப்படிங்கற வேரியபிள் போடுறேன், minus I am b into c அப்படிங்கற வேல்யூ வந்து நான் என்ன சொல்றேன்னா 7 அப்படினு போடுறேன். Now tell me 10 minus 7 is equal to what? 3. இப்போ நான் என்ன கேக்குறேன் அப்படினா, இந்த டோட்டல் வேல்யூவோட வேல்யூ வந்து மேக்ஸிமமா இருக்கணும், that is this is called the determinant of a. இப்போ a ஓட வேல்யூ வந்து மேக்ஸிமமா இருக்கணும் அப்படினா நீங்க என்ன கண்டிஷன் போடுவீங்க? அப்படி a ஓட வேல்யூ மேக்ஸிமமா வரணும் அப்படினா நான் என்ன சொல்றேன் அப்படினா, அப்ப இந்த சப்ட்ராக்ஷன் வராம இருந்தா a மேக்ஸிமமா இருக்கும் நான் சொல்றேன். such that இப்போ இந்த வேல்யூ 0 ஆயிடுச்சு வெச்சுக்கோங்க, அப்ப என்ன வரும்? 10 minus of 0 will become 10. 10 minus 0 will become 10. So if you want to obtain the maximum value for this function, right? So maximum value you attain panna you can make this value as 0. Clear? Directly we can say subtraction value appadina you can obtain the maximum value, right? So the conclusion is what? In order to obtain the maximum value, right, we can say the product of b into c has to be equal to 0. Right? If it is become equal to 0, then matrix determinant of a will become maximum, and that maximum value will be the product of a into d only. Clear? Do remember whichever the things that I am giving here. Why? Because see, the thing is, these things that are we are observing from the matrix properties. While solving the problem, trust me there, it will help you all, right? Because some questions there might be some tricks will be there. Actually, there is not tricks. Basics only. Like that, there will be test. You find out the maximum value and immediately into the maximum value. End up under you might have some confusions, right? That's why I am giving here itself, right? If you will be tested for maximum value, that is the procedure in order to bring out the maximum value. Clear? Yes. Let us proceed further in order to demonstrate, that is understand the property of 3 cross 3 matrix, right? So let me rub these things. These type of questions will be tested only with the 2 mark, that is 2 cross 2 matrix. Why? Because time being, right? Time constraint is the main matter, right? Yeah. Let me rub these things. Let me demonstrate 3 cross 3 matrix. Let us see, let us look at the property of 3 cross 3 matrix, right? Now when we are looking for 3 cross 3 matrix, right, once again we are looking for determinant, right? So I am in need of determinant of the matrix A that can be represented as mod A, right? Now when we are looking for 3 cross 3 matrix, let us take a matrix A, right, and let us take some variable for that. 1 2 1 2 3 1 1 3 2 something I am having here. I would like to know the determinant of this matrix. There are 2 ways to find out the determinant for this, right? So the model number 1 is, method number 1, you have to take the same matrix, right? Let us say 1 2 1, we have to find out the determinant, right? 2 3 1 1 3 2. இப்போ என்ன பண்றீங்க அப்படினா, first in the first column again repeat பண்ணுங்க, such that it is going to be 1 2 1. Again repeat the second column, right? 2 3 3. Complete பண்ணிட்டீங்களா? பண்ணதுக்கு அப்புறம் see there, select 3 variables tilted rows, diagonals, right? 3 variables வர diagonals மட்டும் select பண்ணுங்க. This method is only applicable for 3 cross matrix. 3 variables வர diagonal. Okay guys, once again. See, it's I might have drawn the dotted line such that you will have the clear idea. 1 2 1 2 3 1. Let's say 1 3 2. Let me take 1 2 1 first column, second column 2 3 3. Is it correct? Yes. Now after completing this one, when you end up on, see there, first of all this method is only applicable for 3 cross 3 matrix. And the second thing is what you have to do, you have to select 3 variables or diagonals மட்டும் நீங்க select பண்ணனும். 3 variables will see there in this row, that is in this diagonal I have 3 variables. Whereas if இந்த லைனை select பண்ணீங்கன்னா 2 variables தான் வருது, so you cannot consider this one. Only 3 variables மட்டும் consider பண்ணுங்க. Like that. Next select the second diagonal, similarly select the third diagonal, and then similarly you have to select off diagonal. Off diagonal na, can I draw a line here? No, one variable தான் இருக்கு. இங்க no, 2 variables இருக்கு. இங்க yes, 3 variables. Again here 3 variables. Yes, here 3 variables. I cannot go beyond this. Why? 2 variables தான் இருக்கு. ஃபைண்ட் பண்ணதுக்கு அப்புறம் என்ன பண்றீங்கன்னா the first step இதோட ப்ராடக்ட் எவ்வளோ 1 into 3 into 2 find out the product of diagonal 1 into 3 into 2 will give you 6 plus second diagonal 2 into 1 into 1 will give you 2 plus third diagonal 1 into 2 into 3 will give you 6, right? Sum of diagonals, that is product of diagonals or sum is sum of products of the diagonals, right? Minus sum of product of the half diagonals, right? Our half diagonal 1 into 3 into 1 is going to be 3 plus 3 into 1 into 1 is going to be 3 plus 2 into 2 into 2 is going to be 8, such that its determinant is going to be 6 plus 6 will become 12, 12 plus 2 will become 14 minus 3 plus 3 will become 6, 6 plus 8 will become 14, such that 14 minus 14 will become 0. Clear? Is there a mistake? I think that is correct, right? Okay. Let's see the method number 2, that is method 1. You can go with this method or you can go with the method number 2. The method number 2 is we are going up with the row and column submatrix, right? So let's see, let me rub this one. Let us go ahead with the second method, right? So let me rub this one now. Let us go ahead with the model number 2. In model number 2, if you want to obtain the what I can say matrix A, then determinant A, then you have to do like this. Thing is, you can select any one row or any one column. Guys, listen. Select one row or any one column. It's up to you. You can go with the first row, or you can go with the second row, or you can go with the third row, or you can go with the first column, second column, third column. But we know in our engineering mathematics, right, in our semester curriculum, we all were habituated with the first row. In the first row, what type of என்ன பண்ணிருக்கீங்க? Let me demonstrate. என்ன பண்ணனும்னா see there the first condition, select the first value, right? See first row மட்டும் நீங்க எடுத்தீங்க அப்படினா select the first value 1, right? 1 எடுத்துட்டு what you have to do? Listen, எந்த row செலக்ட் பண்றீங்களோ அந்த கரஸ்பாண்டன்ட் லைக் இப்போ நீங்க ஃபர்ஸ்ட் row செலக்ட் பண்ணிருக்கீங்க அப்படினா ஃபர்ஸ்ட் ரோல இப்போ ஃபார் எக்ஸாம்பிள் I'm taking 1 எடுத்துட்டீங்கன்னா இதோட கரஸ்பாண்டன்ட் காலம் அந்த கரஸ்பாண்டன்ட் row நீங்க நெக்லெக்ட் பண்ணணும். நெக்லெக்ட் பண்ணிட்டு what you need to do thing is you all have to find out the determinant of the subsquare matrix. In the subsquare you can determinant find பண்ணனும். Clear? Slowly understand, right? Slowly understand, right? At the same time இப்போ நீங்க செலக்ட் பண்ணிருக்க வேரியபிள் I am selecting 1 அப்படிங்கிறது A11 தானே? Yes. இப்போ A11 க்குல இப்போ நான் என்ன சொல்றேன்னா இந்த இடத்துல just remember, right, the expression that I am giving, right? Just keep -1 in the power I plus j. You all know what do I mean by I plus j? I denotes row, j denotes column. இங்க row ஓட வேல்யூ எவ்வளோ 1, j ஓட வேல்யூ 1, that is I ஓட வேல்யூ 1, j also 1, such that -1 whole power 1 plus 1 will become +1. அப்ப நீங்க என்ன பண்றீங்கன்னா see that நீங்க செலக்ட் பண்ண வேரியபிளுக்கு எடுத்துட்டு இந்த வேரியபிளுக்கு முன்னாடி, right, actually while finding the determinant the வேரியபிளுக்கு முன்னாடி என்ன வந்திருக்கும் அப்படினா this -1 whole power I plus j ஓட ஃபேக்டர் நீங்க கன்சிடர் பண்ணணும், right? So while finding the cofactor, that is called cofactor of the matrix, slowly you understood, right? So இப்போ என்ன வரும் அப்படினா see there anyway நம்ம செலக்ட் பண்ணிருக்கிறது A11 பொசிஷன், அந்த பொசிஷன்ல இருக்க வேரியபிளுக்கு என்ன சைன் வரணும் அப்படினா +1, and then you can multiply it by subsquare matrix, determinant of the subsquare. Subsquare matrix oda determinant evlo, that is product of diagonal 3 into 2 6 minus product of half diagonal 3 into 1 is going to be 3. And then let's continue our journey. Next நம்ம யாரை செலக்ட் பண்ணிருக்கோம்? We have been selected first row, right? First row மட்டும் செலக்ட் பண்ணிட்டீங்க, right? In the first row let us select the second variable. நீங்க செலக்ட் பண்ற வேரியபிளோட correspondent column and row நீங்க நெக்லெக்ட் பண்ணனும். First step நெக்லெக்ட் பண்ணதுக்கு அப்புறம் ரிமைனிங் இப்போ இந்த ரோவையும் இந்த காலமையும் நெக்லெக்ட் பண்ணீங்கன்னா ரிமைனிங் இருக்கிற மேட்ரிக்ஸ் that is going to be square matrix now. யார் this one and this one, that is square matrix in the sense 2 1, this 2 and 1 2. You have to find the determinant for this, and before that we have to find out this sign, right? இந்த ப்ளஸ் வருமா மைனஸ் வருமான்னு தெரியணும் இல்லையா? நீங்க யாரை செலக்ட் பண்ணிருக்கீங்க A12. Simply you can say நீங்க செலக்ட் பண்ற நம்பர் வந்து ஆட் நம்பர்ல இருந்ததுனா like 1 plus 2 3, 1 add 2 add பண்ணீங்கன்னா you are getting 3. ஆட் நம்பர்ல வந்ததுனா மைனஸ் வரும், ஈவன் நம்பர்ல வந்தா +1 வரும். See that முன்னாடி கேஸ் 1 1 தான் வந்துச்சு, 1 plus 1 will give you 2. ஈவன் நம்பரா இருந்தா என்ன வரும்? ஸ்கொயர் நம்பர் +1 தான் கொடுக்கும், ஆட் நம்பரா இருந்தா மைனஸ் வரும். டைரக்ட்லி you can say. So அப்ப நீங்க டைரக்ட்டா இப்ப மைண்ட்ல ஃபிக்ஸ் பண்ணிக்கலாம். இங்க என்ன இருக்குன்னா A12 12 அப்படிங்கிறது ஆட் நம்பர், so such that you will have a minus here. And then நீங்க வேரியபிள் என்ன இருக்கு? 2 இருக்கு, just consider the variable and then find out its corresponding subsquare 2 1 1 2. Find out the determinant. 2 cross 2 4 minus 1 cross 1 1. Next let us rub this one. Select the third variable, that is third column, right? So let me rub this one, right? 1 minute. Let me rub all these things, right? Let's go ahead with the third person. Third person will be plus or minus or see there A11, A12, A13. 1 3 na 1 plus 3 4 even number, so such that you will have plus. Ang என்ன variable இருக்கு 1, right? In bracket once again correspondent column and row will be neglected. There will be a subsquare matrix. Find out the determinant. 2 into 3 6 minus 1 into 3 3. Clear? Such that if you are finding the determinant for this matrix, 6 minus 3 will give you 2 minus 2 into 4 minus 1 will give you 3 plus 6 minus 3 will give you 3, such that what we are getting here 6 minus 3, did I make any mistake? Yes, guys listen, that is 3. 6 minus 3 3 only, not 2. 2 into 3 will become 6, such that see that 3 plus 3 will become 6 minus 6 will give you 0. Did we got the same answer in the method number 1? Method number 1 நமக்கு என்ன வந்தது 0 தான் வந்தது. Method number 2 also we are getting same 0. Clear? Yes. So our answer is correct. Anyway, it is not necessary that you have to go with only row number 1. You can also repeat the same procedure with row number 2. That is row number 2 or column number 1, column number 2, column number 3. Let me prove it, right? அதனால என்ன சொல்லிருப்பாங்க, நீங்க ஒரு டைம்ல வந்து மேட்ரிக்ஸ்ல ப்ராப்ளம் சால்வ் பண்ணும்போது எந்த ரோல வந்து வேல்யூஸ் வந்து சிம்பிளா இருக்கோ அந்த ரோவை சூஸ் பண்ணி சால்வ் பண்ணுங்கன்னு சொல்லுவாங்க, right? In order to get the simple multiplied values, right? Multiplication factors. Anyway, let's continue our journey with the second row. Just I am demonstrating, right? You can go with any one row. You people have already you have been habituated with the first row. I know many of you had remembered that procedure, and that is the one and only procedure that will be. You will have a strike in your mind with that, right? Let's go ahead. Repeat the same procedure with row number 2. Row number 2 நீங்க என்ன பண்ணுவீங்க, first I am going to select the variable 2, right? So row number 2 select பண்ணீங்க, first variable 2 in front of 2 whether I am going to consider plus or minus. Actually இது யார் இது, this is second row, right? First column A21, right? Second row first column A21 அப்படினா 2 plus 1 3, you are getting minus 2. See there A21 second row first column, so 2 plus 1 will give you odd number na, அப்ப இங்க minus 1 வரும். Clear? Even number இருந்தா என்ன வரும், here plus 1 வரும், right? Sorry, let us start. I am selecting this variable, neglect its correspondent row and correspondent column. Neglect பண்ணா remaining are 2 1 3 2, that is 2 1 3 2. Find the determinant. 2 into 2 4 minus 3 into 1 will give you 3. Let's start our journey with this second. Let me rub this one. Next, what I am going to do, repeat. Select the second variable in the second row, right? That is second row, second variable. Either select number and first, I have to check whether in front of, anyway I have to take this 3. In front of 3, whether I have to consider plus or minus. This is the question, A22. Second row, second column. A22, 2 plus 2, 4 even numbers, such that we are going to get plus. In bracket, right? Let's continue. This corresponding column and row will be neglected and its variables are going to be. Let me rub these things now. I am going to consider 1 1. This is 1 1. Here we are going to consider 1 2, such that it's what I can say determinant. Shall we start? Yes. 1 into 2 will going to be 2 minus 1 into 1 is going to be 1. Let me rub these things now. Yes, it's over. Let's continue our journey with the last variable. Last variable of 1. Whether we have to consider plus 1 or minus 1. I have to check. Second row, third column. Second row, third column A23. Second row, third column A23. 2 plus 3 will give you 5 only now. Odd number. Odd number in the sense I have to keep minus. Do you agree? Yes. Minus coefficient is 1. Its correspondent determinant. I am selecting this variable. Its correspondent column and row will be neglected, such that the matrix values will become 1 2 1 3. Finally, the determinant 3 minus 2 will give you 1. Anyway, we are getting 3 minus 2. Let us conclude. Minus 2. 4 minus 3 will give you plus 1. Plus 3 into 2 minus 2 will give you 1. Sorry, 2 minus 1 will give you 1. Minus 1 into 3 minus 2 will give you plus 1. Such that, see there, minus 2 into minus 2 minus 1 will become minus 3. Minus 3 plus 3 will become 0. Is there any mistake in our answer? No. You can repeat the same procedure with row number 3 or column number 1, column number 2, column number 3. You can go with any value that you want. This is the generalized procedure to find out the determinant of any matrix. I hope things are very clear to you all. I told you there is one more procedure. You can go with either this one or that one. It's up to you. உங்களுக்கு எது ஈஸியா ஃபீல் ஆகுது, you can just follow. People are calling this method number 1 shortcut அப்படி டிஃபைன் பண்ணுவாங்க, right? But I don't think so, right? Because இதை நீங்க பிராக்டீஸ் பண்ணி வெச்சுக்கோங்க. இது உங்களுக்கு மைண்ட்ல வந்துரும். You can either go with that one or this one. It's up to you, right? Okay. Let us run these things now, right? Let us see. That is how we are finding determinant of any matrix, right? That is how we are finding determinant of any matrix. Let us take some other example, right? Because you all have to habituate these things, right? So let us take some other matrix, right? Let me consider matrix is given as 1 1 2. I will always choose what I can say what I easy variables only, because I will let you all to understand these things. Taking complex variables not a matter here, right? Whether the things all understandable by you all or not, that is the matter here. Find the determinant. What I will told you, you can go with method number 1 or method number 2, it's up to you. In method 1 I will solve in method number 1. என்ன பண்ணனும், take the same thing, right? நீங்க என்ன பண்ணுவீங்க, 1 1 2, I have to consider 3 2 1, and then I have to consider 1 3 2, then I have to repeat 1 3 1, and then 1 2 2. That is first two columns will be reflected once again, and then simply we can do product of this first diagonal. 1 into 2 into 3 will be 6, plus 1 into 1 into 1 will be 1, plus 2 into 3 into 2 will be 3 into 2 6, 6 into 2 will be 12. First half is over, minus second half 1 into 2 into 2 will give you 4, plus 2 into 1 into 1 will give you 2, plus 3 into 3 into 1 will give you 9. What is the answer? 12 plus 6 plus, that is 12 plus 16 plus 1 will become 19, because 18 plus 1 will give you 19, minus 4 plus 2 6, 6 plus 9 15, such that 19 minus 15 will give you 4. Any mistake? No. That is how we are finding determinant. What I have done, select the first diagonal, second diagonal, third diagonal. Its product, that is sum of product of diagonals, and then minus sum of product of diagonals. Clear? That's all. That is how we are finding determinant of the matrix in method number 1. You can also go with the method number 2. In method number 2, what will you do? First value, that is plus 1 into 4 minus 3 will give you 1, minus 1. Second, 3 into 2 6, 6 minus 1 will give you 5. Third one, plus 2, 3 into 3 9, 9 minus 2 will give you 7. Such that it is going to be 1 minus 5 plus what I can say 14, right? So 14 plus 1 will give you what? 15. 15 minus, see, I am getting some wrong answer here. Did I make any mistake? Let me check it. 1 2 into 2 4, 4 minus 3 will give you 1, minus 1, minus 1 in the sense I have to neglect. 3 into 2 6, 6 minus 1 will give you 5, and then I should keep plus 1 only, na? That is a11 a12 a13, and then 2, let's rub this one. 3 into 3 will give you 9, 9 minus 2 will give you 7, right? So such that 2 into 7 will be 14. This is 1 minus 5, I think this is 15, 15 minus 5 will give you 10. Here somewhere I made mistake. Recheck பண்ணுங்க. 1 2 3, that is 6, right? And then 1 into 1 into 1, like 3 into 2 6, 6 into 3 12, minus what I have done, 1 into 2 into 2 will be 4, and then plus 2 into 2 into 1, that is 2 only. 3 into 3 9, 9 into 1, that is correct only. Where I have made mistake, 12 plus 6 will give you 18, 18 plus 1 19 only, minus 11 15. I think I made mistake somewhere again. Okay, please cross check by yourself, right? I don't want to waste my time. Where I have made a mistake here, okay, let me check it by myself once again. This is going to be 4, minus 4 minus 3 means that is 1 into 4, 6 minus 1 5 only. This is correct, right? I think here only I made mistake somewhere. Did I 1 3 1? Oh, sorry guys. At this point I made mistake. See. Anyway, we are not going to 2 3 3 into 3 9, 9 to 18, right? In this one, so that is going to be 18. Now it is become correct, right? 9 18 plus 1 19, 19 plus 6 it is going to be 25. Sorry, please correct it by yourself. Here it is 3. See there, I have 3, I put 2. Okay, fine. Matrix wrong எடுக்கல sir, method 1. Matrix wrong எடுக்கல, value தப்பா எடுத்துட்டேன். Yeah. See, that is general method. It is applicable for all 3x3 matrix. Let's rub this one. That's all. That is how we are finding determinant for 3x3 matrix. I hope these things are clear to all. Let us see. I will take one more example. See, that is generally applicable for all type of matrix. Don't think that is 3 cross 3 matrix அப்படினாலே நீங்க அந்த procedure யூஸ் பண்ணிக்கலாம், right? So let me prove it by one more matrix. Okay. Shall we start? Yes. Do it by yourself at very high speed, right? Do it. Don't wait for me because I might have made mistakes like this, right? But procedure is correct. 1 3 1 2 2 1 1 1 3 2, right? Let me check it myself once again. 2 1 2 1 3 2 1 2 4, right? Shall we start? Yes. Start பண்ணுங்க. That is going to be what? 2 into 3. Okay, அப்ப அப்படியே போட்டனால 2 into 3 6. 6 times of 4 will give you 24, right? Similarly, plus 1 into 2 into 1 will give you 2, plus 2 into 1 into 2 will give you 4. 140 is over, minus second part. 1 into 3 into 2 will give you 6, plus 2 into 2 into 2 will give you 8, plus 4 into 4 into 1 into 1 will give you 4. What is the answer? 24 plus 6 will give you 30, minus 6 plus, that is 18. Such that if I subtract these two, that will give you what? 12, right? Right. You can also cross check. Let us take this one to another procedure. 12 minus 4 will give you 8, right? Second is 4 minus 2 will give you 2, plus 2 into 2 minus 3 will give you minus 1. Cross check பண்ணிக்கோங்க. That is 16 minus 2 will give you 16 minus 4 will give you 12 only. Is there any changes? No. Procedure will be remain same, right? That's correct. Fine. So that is how we are finding determinant for 3 cross 3 matrix, right? I hope things are clear to all. Right now, what is the next step? Suppose if I am facing 4 cross 4 matrix, same procedure, right? But that method is not applicable. We can go with the method number 2 when we are facing 4 cross 4 matrix, right? Let us take one example for 4 cross 4 matrix and then I will demonstrate. For example, I have 1 1 1 2 2 1 3 1 3 1 2 1, right? And 3 3 2 2. Let's take some simple value. We have to understand that's enough, right? Now the procedure will be remain same. In the procedure, first select the row number 1. Let us go ahead with the row number 1, right? Row number 1 la first variable select பண்ணுங்க. First variable க்கு முன்னாடி என்ன வரணும்? Once again it will be written as what? This is A11, A12, A13, that is going to be A14. We all know, right? Such that what I am going to get, let me write this one also. This is A21, A22, A23, A24. You can repeat this procedure up to last. Now, next what I am going to do, the second thing is I am going to consider once again, right? First, select the first variable 1. In front of 1, whether we have to keep positive sign or negative sign, we should keep positive sign. Why? Because 1 plus 1 will give you even number. So I have to keep plus 1. Next, open a big bracket because immediately after selecting the first variable, I have to eliminate the correspondent column and the correspondent row. Now, if you are looking for, see there, you will have a new 3 cross 3 submatrix. If the 3 cross 3 matrix, you all know how to find out the determinant. Shall we proceed? Yes. If for this correspondent determinant, see, இதோட correspondent submatrix is the 3 cross 3. Find பண்ணுங்க. என்ன வரும்? That is 1 into 2 into 2 4 minus 2 will give you 2 minus 3 into, right? I am neglecting this corresponding row and column. 1 into 2 minus 3 will give you minus 1 plus 1 into 2 minus 6, right? 2 minus 6 will give you minus 4. See, you no need to wait for me. If I make any mistakes, correct it by yourself because I am not teaching any concepts here, right? Mathematics things. Fine. Let us complete. That is first variable. It's over with this. Second variable என்ன வரும்? If I am putting plus 1 here, இப்போ என்ன பண்ணோம்? 1 plus 2 will give you 3, odd number. அப்போ minus 1. Minus 1 choose பண்ணிட்டு again open up a big square bracket and then let me rub these things because we have to select we are getting ready for second 3 cross 3 matrix. Let's see where is our second 3 cross 3 matrix. See, if I select this one, neglect the correspondent column and row. Keep rest of people. Here record 2 3 1, that is 2 3 1 3 2 1 3 2 1 3 2 2 3 2 2. Shall we proceed? Yes. First 3 cross 3 matrix, we are very familiar with this, right? So 2 into, what I have to do, 2 into 4 minus 2 will give you 2, exactly. Minus 3 into 6 minus 3 will give you 3, and then, sorry, yeah, that is correct. And then 1 into, anyway, here I have 1, 6 minus 6 will going to be 0. It's over. Repeat the same process for the third variable. 1 plus 3 will give you even number, such that I have to keep plus 1. Let me open up the square bracket. Is that portion is visible to you all? Yes, that's visible. Yeah. Third row. After select panenga, repeat the same procedure. Same procedure, right? Sometimes we will tested for 4 cross 4 matrix also. But the beauty is 4 cross 4 matrix கேட்டாங்க இதுல நிறைய வேல்யூஸ் வந்து 0 ஆக்கிட்டு இருப்பாங்க. Simple answer வரணும்ல, time consumption will be there. In order to bring out the answer immediately, you can observe. Exam ல பாக்கும்போது definitely I will remind, that is உங்களுக்கு என்னோட ஞாபகம் வரும். என்ன கொடுத்திருக்காங்க, 4 cross 4 matrixல நிறைய வேரியபிள்ஸ் 0 ஆயிடும். Like if you observe, இதுல 16 variables இருக்கா, almost some 5 to 6 variables they will make it as 0, such that you will get the answer within 2 steps or 3 steps, right? Time consumption is very matter, that is matter here, right? Take the third one. What I have to keep, 1 plus 3 means plus 1, such that if you open up the square bracket, let's see, neglect the correspondent column and row, right? If I neglect these two, what I have to do, let me rub these things. Wait a minute, it's freezing again, right? Because of chillness. Fine, let's go ahead. 2 3 3 1 1 3 1 1 2. Shall we start? Yes. Fine. 2, we know 2 into 2 minus 3 will give you minus 1, exactly. Minus 1 into 6 minus 3 will give you 3, exactly. Plus 1 into, what I can say, 9 minus 3 will give you 6. Okay, correct. Next, 1 plus 4 will give you 5, odd number, such that I have to keep minus 1, not minus 1, minus 2, because coefficient is 2 now. Shall we start? Yes. Correspondent rows and columns are being neglected. This is the correspondent column, correspondent row. So I have to choose these 3 cross 3 matrix. Let's go ahead, right? So that is 2 into, right? 1 into 2. 2 minus 6 will give you minus 4. Yes. Minus 1 into 6 minus 6 will give you 0. Exactly. Plus 3 into, right? Plus 3 into 9 minus 3 will give you 6. It's over. Yes. That's all. Apply add and get the answer. That is how we are finding determinant for 4 cross 4 matrix. Trust me, dear, in your examination, definitely they will make at least some 4 to 5 variables are going to be 0, because time consumption is the main matter. கண்டிப்பா அப்படிதான் வரும். அதனால 4 cross 4 அதெல்லாம் வரியே பண்ணாதீங்க. மேக்ஸ் ரொம்ப ஈஸியா இருக்கும். 2 steps 3 steps you can bring out the answer. யோசிக்கிறதுலாம் இங்க ஒர்க்கே இருக்காது. Question read பண்ணி you can keep your answer. Clear? Yes. Let us rub this one. I hope things are very clear to you all. That is how we are finding determinant of the matrix. Okay, let me rub this one quickly. Now after finding the determinant of the matrix, what is our next task? Let us see some of the properties of the determinant, right? So we have to observe the properties of the determinant, because determinant is quite easy, but now we have to understand few more properties, right? Let me demonstrate, right? For few people I will give proof, because you have to trust me now. For few people I will let you to prove. That's your task, right? Yes. Let me rub these things. Right. Let us. Okay. It's really freezing. Fine. Next, what we are going to do? Let us see some of the properties. Now let's take some matrix here. Let us take matrix A, and I would like to keep some value here, 1 3 4 2. Let's keep some value for this. Now I would like to find out the determinant for this matrix. What would be the determinant? Can anyone tell me? Determinant is going to be product of diagonal is 2 minus product of half diagonal. 4 into 3 will give you 12, such that it will be equal to minus 10. Exactly, that is true. Now let me take A transpose. We all know what do we mean by transpose. Transpose in the sense, rows are become columns, columns are become rows, such that the first row will become first column, the second row will become second column, right? So this matrix can be written as 1 3, and the second matrix it can be written as 4 2, such that if you are finding determinant for, find out the determinant for A transpose, that is going to be 1 into 2 will give you 2 minus 4 into 3 will give you 12. So 2 minus 12 will give you minus 10. Is there any changes in your answer? Is there any changes? No. while going from A to A transpose, there are no changes in the determinant of the matrix. So what will be the conclusion? Determinant of matrix A will always be equal to determinant of matrix A transpose. That is the first property. Clear? Property number 1. It's very important, so try to keep it in your mind, right? So let us rub this one. Let me take the second one, right? Let me rub this one and let us take the second one, right? Yeah, let us rub these things. Now what I am going to do, let me take a matrix A and let us assume this value is 1, 2, 2, 3. Enough. Let us take matrix B. Matrix B value, assume like that, that's going to be 1, 1, 2, 3. Enough. Right? Yes. Now what I am going to do, just to find out the determinant of both matrix. Matrix A determinant equal to 1 into 3, 3 minus 2 into 2, 4, such that this is going to be minus 1. Now, second person, matrix B, right? And its determinant will be equal to 1 into 3, 3 minus 2 into 1 will be 2, such that 3 minus 2 will be 1. Yes, just to keep it. Now, first find out the product of A into B. Matrix A and B. What will be the answer? Let me do it. For that, I have to consider matrix A and matrix B. That is 1, 2, 2, 3. Matrix B is 1, 1, 2, 3. Right? Let's see. Its resultant answer is going to be. We all know. First, in order to do the matrix multiplication, what we have to do? The first thing is select the first row with the first column. We have to multiply them, and then that answer will be projected here. 1 into 1, right? Plus 2 into 2 will give you 4, right? And then select the first row of the matrix 1, select the second column, right? Such that 1 into 1, right? Plus 2 into 3 will give you 6, right? Similarly, let me rub this one, right? Let us go ahead with the second row, first column. Then what happens? 2 into 1 will give you 2, plus 3 into 2 will give you 6. Similarly, second row with the second column. 2 into 1 will give you 2, plus 3 into 3 will give you 9. That is how we are doing matrix multiplication, right? Let's see. Now, the next conclusion is, wait a minute. Its resultant matrix can be expressed as 1 plus 4 will give you 5, 1 plus 6 will give you 7, 2 plus 6 will give you 8, 2 plus 9 will give you 11. Can anyone find out the determinant for this matrix? 5 times of 11 will give you 55. Correct? 8 times of 7 will give you 56. 55 minus 56 will give you minus 1. Do you agree? Yes. That is the determinant of AB. Correct? This is matrix AB. Its determinant is minus 1. Now, let us take matrix A determinant, multiply with the matrix B determinant, such that this is minus 1, this is plus 1. 1 into minus 1 will give you minus 1. What is the conclusion here? So, the next property is determinant of AB should be equal to determinant of A dot determinant of B. That is the second conclusion. Clear? Second property. Property of your determinant, right? So, let us take the third one. Let me rub this one, right? Let us rub these things, right? Yeah. Just you can test it, right? Just you can test it by yourself. Anyway, you have to satisfy now. Some of you might have confusions. In order to clear that, I am doing this matrix multiplication setup, right? Some other doubts will be cleared if I do the operations. Let's take matrix A once again. Let us take some variable 1, 2, 3, 4, right? Now let me select matrix B. Let us go ahead 1, 2, 3, 1, right? Yes. Now what I am going to do? I know matrix A and matrix B, right? Now I would like to know the value of matrix A determinant, right? That is going to be what? Let us see. Once again, 1 into 4 minus 3 into 2, 6. 4 minus 6 will give you minus 2. Determinant of B, 4 minus 3 will give you plus 1. Right? Now, let us find the matrix A plus B. Matrix A plus B na enna pannom? Kavaninga, A plus B na addition. Addition எப்படி பண்ணுவீங்க? Addition அப்படினா see there. இங்க A11 இருக்கா? இங்க A11. this is A12, this is A12, this is A21, this is A21, this is A22, this is A22. While doing addition, A11 plus A11, we have to add A12 with the A12, A21 with the A21, A22 with the A22. That is matrix addition. Such that 1 plus 1 will give you 2, 2 plus 3 will give you 5, 3 plus 1 will give you 4, 4 plus 4 will give you 8. Can you please find out the determinant for A plus B? Determinant of A plus B will become 2 into 8 will become 16 minus 5 into 4 will be 20, such that 60 minus 20 will become minus 4. If I add matrix A, determinant of matrix A with the determinant of matrix B, what we are getting? Minus 2 plus 1 will give you minus 1. Now tell me whether they are being equal or not. No, they are not equal. So the conclusion is determinant of A plus B will be not equal to determinant of A plus determinant of B. Many of you having these doubts here. The thing is, immediately you are thinking, if determinant of A into B is equal to determinant of A dot determinant of B, then determinant of A plus B also equal to determinant of A plus determinant of B. That is wrong actually, right? This is the correct statement. Addition wise they are not equal. Only product they will be satisfied. Determinant of AB equal to what? Determinant of A dot determinant of B. Clear? I hope things are clear to you all, right? So in the same way, let me demonstrate some other things, right? Yeah, let us rub these things. Okay. Now next, for an example, I have matrix A, right? And its determinant. For an example, 1, 2, 2. Let us take 3, right? Let me select reduce some variable. Let us make it as 2, 4. Let us make it as 3. That's our wish, right? Determinant of A is what? 2 into 4, 8. Minus 23, 6. It will be equal to 2. Clear? Determinant of matrix A is 2. Now I would like to find out the A inverse matrix. What is A inverse? Inverse matrix I will talk later. But anyway, right now I am just giving introduction. Inverse matrix for the 2 plus 2 matrix. Anyway, general formula is A inverse equal to 1 by determinant of A into adjoint of A. I am just giving introduction. Zone we will realize all those things. Don't be panic. Okay, fine. Now here for a 2 plus 2 matrix, let me write adjoint of a matrix can be written as adjoint of a 2 cross 2 matrix should be equal to. If a matrix is given, if you want to know the adjoint of A, then you all have to do interchange the position of the diagonal, right? Diagonal in the sense, in place of 2 I have to consider 4, in place of 4 I have to consider 2. Interchange these two people position such that it will become 4, it will become 2. At the same time, change the sign of off diagonal person, right? In the off diagonal I have 2, then consider minus 2. Here I have 3, then consider minus 3. So what will be the conclusion? In order to get for your 2 cross 2 matrix, actually this is called shortcut only, this is not standard procedure, right? So here while going from for a 2 cross 2 matrix, if you want to find out the adjoint of A, what you have to do? Off diagonal elements, right? That is off diagonal elements will be multiplied by a factor of minus 1 in case of matrix A, whereas diagonal elements are going to be interchangeable, right? So diagonal values are going to be interchangeable, right? That's all. That is the procedure to obtain the value of adjoint of the matrix. How we are finding out the determinant of the matrix? Determinant of A is product of diagonal minus 2 into 4 will give you 8 minus 3 into 6 will give you. Already we found the determinant, right? Anyway, let me write the answer directly. That is 2. 8 minus 6 will give you 2 only. So that is the determinant of the matrix. Now let us find out the A inverse here. So A inverse you find பண்றீங்க அப்படினா, so A inverse matrix will become, right? So let me write the answer 1 by 2 into, right? A inverse equal to 1 by 2 into, let us write 4 minus 2. See that A inverse equal to 1 by determinant of A into adjoint of A. So 1 by determinant of A is 2 into adjoint of A is this one. Let us substitute all these variables. Minus 3, 2, right? Now what will be the conclusion here? This is A inverse. Now I would like to know the determinant of A inverse matrix. Find out the determinant. For that, இப்போ நீங்க என்ன பண்றீங்கன்னா உள்ள இருக்க ஃபேக்டரை இந்த 2 ஆல மல்டிப்ளை பண்றீங்க. இந்த 2 உள்ள பாஸ் பண்ணுங்க. If I pass 2 here inside, right? Then what will happen? This 4 is getting divided by 2, this 2 is getting divided by 2, this 3 is getting divided by this 2 also getting divided by 2. Such that 4 by 2 will become 2 minus 2 by 2 will become minus 1, minus 3 by 2 minus 3 by 2 only, it will become plus 1. Find out the determinant now. Then the determinant of become product of diagonal will be 2 minus product of off diagonal. Off diagonal sense minus 1 into minus 3 by 2 will become plus 3 by 2. Such that what is the equivalent value? See there, 2 is 2 minus 3 by 2 is 1.5. So 2 minus 1.5 will give you 0.5 or 1 by 2. What I have understood, determinant of matrix A, determinant of matrix A is equal to 2, whereas determinant of A inverse equal to 1 by 2. What is the relation between these two people? The relation is determinant of A inverse should be equal to 1 by determinant of A. Do you agree with me? Yes. Just if I take the reciprocal for this, then that will give you the value of determinant of A inverse. So the correct property for the next one is what? Determinant of A inverse should be equal to 1 by determinant of A, right? Hopefully you all have understand these things, right? So let me rub this one. Take small values, right? You have to understand that's all. That is enough, right? Let me rub this one. Yeah. Now next term, right? Like let us take what we can say. Let us take some matrix A. Let us take some matrix A, right? In matrix A, let me take 1 2 1 2 1 2 1 2. Find out the determinant. Okay, let us do one thing. Wait, guys. 1 2 na 3 4 எடுத்துக்கலாமா? Okay, fine. Find the determinant. Determinant of matrix A should be equal to 1 into 4, yes, 4, minus 3 into 2 will be 6, na? Yes, 6. So 4 minus 6 will give you minus 2. Exactly, that is correct. Now, see, we all know this is column number 1. This is column number 2. Now, I said just interchange column number 1 and column number 2. Right? Column number 1 and column number 2 I will interchange பண்ணுங்க and then find out the determinant. Right? Let me call this. Yeah. After interchanging the matrix, you are going to get what I can say 2, 4 will be here, 1, 3 will be here. Right? Again, find the determinant for A dash. If I find the determinant for A dash, what will you get? 2 into 3 will give you 6 minus 4 into 1 will give you 4, such that 6 minus 4 will going to give you 2. Clear? Yes. Let us see A double dash. Let us consider some other variable. Now what I am going to do? Let me call it as row number R1 and let us call it as row number R2. Now what I am going to do? Just interchange the position of R1 and R2. If I interchange the position of R1 and R2, then it will become 3 4 1 2. Do you agree with me? I told you interchange the position of R1 and R2. R2 in place of R1 we are going to consider R2. In place of R2 we are going to consider R1. Such that finally determinant of A double dash. What I will get? 3 times of 2 will give you 6 minus 1 into 4 will give you 4. Such that 6 minus 4 will give you 2. Hey, what is the conclusion here? See, this is the matrix. For matrix A, our determinant is what? Minus 2. When I am interchanging the position of columns or when I am interchanging the position of rows, in resultant sign, signature, right? Sign of the determinant will change. Do you agree? Yes. Make the next statement, right? So whenever while interchanging the position of rows and columns, if we interchange 2 rows, right? If we interchange 2 rows or 2 columns, then in resultant determinant of that matrix sign will change, right? Sign, right? Only sign. In the determinant of that matrix, sign only will change. Clear? That is the next property of your matrix A. I hope things are very clear to you all, right? Suppose if I take the next one, let me rub these things, right? Let us rub this one, right? So let us rub these things now. While interchanging 2 rows and 2 columns, right? These things will happen, right? Yes. So the next property of the matrix. The next property of the matrix is going to be, let us consider a matrix 1. Shall we take 3 cross 3 matrix? Yes. Let us take 3 cross 3 matrix, right? So that is going to be 1, 2, 3. Let us take 1, 4, 1. Let us consider 2, 4, 6. I would like to know the determinant of this matrix. What will be the determinant of this matrix? Determinant is equal to determinant of A is equal to, right? So determinant of this matrix is equal to, let us see, 1 into in bracket 4 into 6 will give you 24. 24 minus 4 will give you 20. Shall I write the answer directly?
Of course. Minus 2 into its corresponding column and row will be neglected. 1 into 6 minus 2 will give you 4 exactly. Next, so 1 minus 2 we have to consider plus 3, right? Let us rub this one. 4 minus 2 will give you, 4 minus 8 will give you minus 4. Okay, such that its determinant is going to be, let me complete. Twice of 4 will be 8. 3 times of 4 will be 12. But minus 12 minus 8 minus 20. 20 minus 20 will become 0. Sir, why this determinant will become 0? Why? Because there I found two dependent rows. Did you notice? See there, this is row number 1. Yes, this is row number 3. If I take row number 1 and if I simply multiply by 2, then I will get R3. Or I can say, if I simply take R3, if I divide it by 2, then I will get row number R1. Such that, see there, if two rows are dependent each other, if two rows are dependent each other, or if two columns are dependent each other, two columns in the sense, let me prove it. Listen, let us take 1, 2, 1, 1, 3, 2. Let us take 1, 2, 1. What I have done? See there, column number 1 and column number 2 are identical to each other, or there might be identical or not. If it is not product or not. For example, if I multiply by 3, then it will become 3, 6, 3. See there, just to take row number 1, multiply it by a factor of 3, such that you will get, column number 1. If column 1 will be scaled by a factor of 3, then I will get column number 3. Such that if I find any interrelation between the interrelation between the columns or rows, then its corresponding determinant is going to be 0. Shall we prove it? Yes. Check it this one. 1 into 9 minus 12 will give you 9 minus 12 will give you minus 3. Exactly. Similarly, minus 1 into 6 minus 6 will give you 0. Yes. Plus 3 into 4 minus 3 will give you 1. Such that, see that minus 3 plus 3 will become 0. Do you agree? So what is the conclusion? While finding the determinant, so the next property is, if two rows or columns, right? If two rows or two columns are identical to each other, or if one row will become the multiplication, right? That is, see there, if one row will become, right, will become the scaling factor of another row, right? So if I take one more, row irukku, in the row oda scaling factor ஒரு row வந்துச்சு அப்படினா, then also your determinant will become 0, right? If one row will become the right scaling factor, if the row number 1 will be scaled by a factor of 2, then I will get row number 3, right? So such that, what is the conclusion? The conclusion is, if the rows are interdependent, right? If the rows are dependent on each other, or if the columns are dependent on each other, then it results that determinant of that matrix will going to be equal to 0. That is the next property, right? If the rows are dependent on each other, or if there is any dependence between the columns, then its corresponding determinant of that matrix will going to be equal to 0, right? So let us see the next property. Let me rub this one. Guys, all the properties are very important, because in your examination, from matrix side, even in your TRB, TNEB exams at all, at many times you will be tested by theoretical questions. Because from this area, there are many properties. Actually, there is not properties, observations. இப்போ நம்ம இதெல்லாம் டெஸ்ட் பண்ணி பார்க்கும்போது இப்போ இப்படி எல்லாம் இருக்கு, ஒரு மேட்ரிக்ஸ்ல வந்து ரெண்டு ரோ வந்து ஒரே மாதிரி இருந்தா அது டிட்டர்மினன்ட் வந்து 0 ஆகுது. இதெல்லாம் வந்து நம்ம சும்மா அப்படி பிராக்டிஸ்ல பேப்பர்ல போட்டு பார்க்கும்போது நமக்கு கிடைச்சிருக்கு. அந்த ரிசல்ட் எல்லாம் வச்சு தான் எக்ஸாம்ல தியரிட்டிக்கல் क्वेश्चंस ஃப்ரேம் பண்ணுவாங்க. So some of you might not understand these things, so you might lose some 1 mark or 2 mark questions, right? That is not even worth for 5 marks if you remember the properties. Okay, fine. Let's take the next one. Suppose I have the determinant, right? The determinant values, for example, I will take 1 to 1. Let's see 3, 2, 4, and I have 0, 0, 0. Can anyone find the determinant for this matrix? Let's see what happened. Determinant of this matrix will be equal to, first one, 1 into 2 into 0 minus 0 into 4 will become 0. Minus 2 into element corresponding column and row, 3 into 0 minus 4 into 0 will become 0. Yes. Plus 1 into, again, if I eliminate its corresponding rows and columns, 3 into 0 minus 2 into 0 will become 0, such that the net value is going to be equal to 0. What is the conclusion? If any one row, right, in any one of the row, in a given square matrix, right, if any one row of each elements, or if any one column, right, row or column, it does not matter. You can also consider column like 0, let me consider 0, 0, 0, let us consider 1 to 1, let us consider 3, 4, 5. Can you find out the determinant for this matrix? Let's see what happens. If I find the determinant for this matrix, first I have to select 0, 0 into what I have to consider, okay, 0 into anything will give you 0 only, na? Anyway, 5 into 4, that is a 10 minus 4 will give you 6. Second, I have to choose minus 1. right? If I choose minus 1, then correspondent column and row, if I neglect this one, 0 into 5, 4 into 0 will going to be 0 only. Consider third person plus 3 into, if I neglect corresponding these two people, 0 into 1, 2 into 0 will going to be 0 only, such that is going to be 0. What is the conclusion? The conclusion is, if any matrix, right, if all rows, if all values of the selected row, any one row, right, if all row or if all elements of any one row or one column are going to be 0, then its correspondent determinant of the matrix also going to be 0, right? In a selected matrix, right, if each and every elements of a row or column are going to be 0, then its correspondent determinant also going to be 0. That's all clear. That is the next property. So let me rub this one. Let us consider the next one, right? Yeah. Yes. Okay. Let us consider matrix A, right? See, first of all, we have seen the A inverse formula. A inverse formula can be written as A inverse equal to 1 by mod A into adjoint of A. 1 by mod A into adjoint of A. Right? From this, if I find, just to pass this mod A to this side, that is, determinant of A should be equal to A inverse and pass or otherwise, let me do one thing. Take this matrix, right? In this matrix, I am going to do one thing. In the LHS, I am multiplying it by A. In the RHS also, I am going to be multiplied by the same quotient. See there, guys, listen. In this matrix, A inverse to முன்னாடி A வால மல்டிப்ளை பண்றீங்க அப்படினா இங்கே நீங்க என்ன பண்ணனும்? இந்த மேட்ரிக்ஸ்க்கு முன்னாடி A வால மல்டிப்ளை பண்ணனும். லைக் நீங்க மேட்ரிக்ஸ்ல மல்டிப்ளிகேஷன் போடும்போது இங்க வந்து A டாட் A இன்வெர்ஸ் னு போட்டு இந்த பக்கம் போயிட்டு 1 by determinant of A into adjoint of A, that is correct, into A inverse அப்படினா எழுத கூடாது. Because your matrix in matrix multiplication, your matrix multiplication is not always satisfies the properties of commutative. Adana commutative in digital electronics, it's going on. In digital electronics, we saw the properties called commutative. There I told you product of A into B is equal to B into A. Of course, that's correct in digital. It is also correct in normal multiplication. Like I can say 2 into 3 equal to 3 into 2. That is correct. But in matrix multiplication, it may or may not be. I cannot say this statement is always true. There may be controversy. இது எப்பவுமே ட்ரூ ஆகும் அப்படிங்கிறதுக்கு நம்ம ப்ரூஃப் கொடுக்க முடியாது. ஸோ தி கன்க்ளூஷன் இஸ், நீங்க இந்த பக்கம் இந்த क्वेश्चन ஏவால மல்டிப்ளை பண்றீங்க அப்படின்னா ஆர்ஹெச்எஸ்ல போயிட்டு அதே क्वेश्चन நீங்க என்ன பண்றீங்க, பிக்கு முன்னாடி அங்க என்ன பண்ணணும், அதே மாதிரி ஆர்ஹெச்எஸ்ல இருக்க மேட்ரிக்ஸ்க்கு முன்னாடி தான் நீங்க ஏவல் கன்சிடர் பண்ணணும். யூ cannot interchange the position. If you interchange, then that will yields to wrong answer. While doing matrix multiplication, this property is very important, right? So anyway, what is the conclusion here? This is wrong. This statement is wrong. So conclusion is what? I will have to consider this whole matrix multiplied by A on both sides, such that A dot A inverse will become A bar 0 equal to, here it is going to be A upon determinant of A into adjoint of A. Always, see guys, we all know x power 0, anything power 0 except infinity will be equal to 1. Do you agree? Yes, that is in normal multiplication, right? In matrix, anything power 0 except infinity will be equal to unit matrix I. Clear? Yes. So that is in matrix, right? And I had given these things when I was talking about control system, state space analysis, right? We had a term is called S minus A. அங்க நான் என்ன பண்ணிருப்பேன், S is a constant, right? It's a simple parameter, scaling factor. But A is a matrix. A parameter or a constant cannot be separated from matrix, or a matrix cannot be separated from a scaling factor. Such that அப்ப இந்த scaling factor நீங்க வந்து matrix ஆ மாத்தணும் அப்படிங்கறதுல I was multiplied by unit matrix. I hope you all remember. Unit matrix வந்து உங்களோட ப்ராப்பர்ட்டியை மாத்தாது, because determinant of the unit matrix will be equal to 1. So product of 1 into x will be x only. So the property of x does not be changed because of this 1. Like that, property of s not going to be changed because of the I. But in order to do the matrix subtraction, we are transforming this value from scaling to matrix. If you want to transform ஒரு arbitrary ஒரு constant இருக்கு, அதை நீங்க மேட்ரிக்ஸால அதை மேட்ரிக்ஸா நீங்க கன்வர்ட் பண்ணனும் அப்படினா you will have to multiply by unit matrix. Sir, I have a term 5. இந்த 5 வந்து நான் மேட்ரிக்ஸா மாத்தணும். Just multiply by I have a term e power x. I would like to transform. இது வந்து நான் மேட்ரிக்ஸா மாத்தணும். Multiply by I. So unit matrix is going to help us to transform any variable from arbitrary, from constant domain to matrix domain. Right? So the conclusion is, in matrix, whenever you are finding a term, anything over 0 will be equal to unit matrix, don't forget. And then you can pass this determinant of A to the left hand side. See, it's a constant. Determinant of A அப்படிங்கிறது ஒரு வேல்யூ. அதை நீங்க எங்க வேணாலும் கன்சிடர் பண்ணிக்கலாம். அதுக்குள்ள நீங்க யோசிச்சுக்கணும், right? A equal to what? A into adjoint of A, right? So the conclusion is what? That is A into adjoint of A. So what is the conclusion? The next property is A into adjoint of A should be equal to what? Determinant of A into I only, what? Determinant of A only. So determinant of A into I, that is equal to this one. Clear? Just to remember. Right? Now let us see the next property. Let me rub these things. So the next conclusion is, that is observation only, right? For an example, if you want to find out the determinant of the adjoint of a matrix, right? So for an example, let us take matrix A, right? And that matrix A, I have some variable like 2, 1, 3, 4. I would like to find out the determinant of matrix A. Can anyone? 8 minus 3, that is 2 into 4, 8. 8 minus 3 will give you 5. Exactly true, sir. Now, I would like to find out the adjoint of A. Adjoint of A. What do you mean by adjoint of A? If you want to find out the adjoint of A, what have I told you? Interchange the position of diagonal elements. Change the sign of off diagonal elements. Exactly, that is true. Can you please find out the determinant of the adjoint of A? If you want to know the determinant of the adjoint of A, that it should be equal to 4 into 2 will be 8 minus 3 into minus 1 will become plus 3, such that 8 minus 3 will give you 5. Will give you 5, right? Don't think that the value of adjoint of A is exactly equal to mod A. Let me write the actual relation. The actual relation is determinant of adjoint of A should be equal to determinant of A in the power of n minus 1. Clear? Such that its answer is going to be what? Here n denotes the order of the matrix. N denotes the order of the matrix. Since given it is 2 cross 2, so the value of n equal to 2. So the conclusion is what? If you want to determine adjoint of A would determine வேணும் matrix A would determine find பண்ணிட்டு அதோட value நான் find பண்ணிட்டேன் in the power n is equal to 2. Order is 2 now, so 2 minus 1. That is going to be the answer. That is how we are getting this one. That is the actual relation between of these two guys. This is the actual relation between of these two guys. Okay. Anyway, I can also prove with the help of 3 cross 3 matrix. Understood these things, that is enough. Don't waste our time, right? After that, we are going to get the same result. So let me run this one. Yeah. So the next conclusion is, we understood adjoint of A, right? Determinant should be equal to determinant of A in the power of n minus 1. Yeah. In the same way, if you are requested to find out the adjoint of A, right? Already adjoint எடுத்து ஒரு மேட்ரிக்ஸ்க்கு திரும்பவும் நீங்க adjoint எடுத்துட்டு அதுக்கு நீங்க determinant find பண்ணீங்க அப்படினா then the term will become equal to determinant of A whole power n minus 1 whole square, because twice of adjoint of A, so it will become twice of, right? So that is n minus 1 whole square. Suppose if I take again, if I increase the adjoint of A, then what will you get? You all are going to get, the answer is you have to raise the power to 3 times, right? Such that you are going to get n minus 1 whole power 3. Clear? That is the next property. Guys, many of you, right, I have forgot this thing. That is very, I think last time only in the TNEB, in the same type of question you have been tested, right, for 2 more question. But that is not worth for 2 mark. If you don't remember the property, you cannot give the answer. I do remember something they asked 100 plus 100 matrix something there, right? I did remember because 2 years ago now that exam was being conducted. But the question was very easy. I think 3 years, right? Not 2 years. It happened 3 years ago. Yeah. Let me rub this one. Okay. So what I have understood, we understood the basic fundamental properties of the matrix, right? So determinant. Now from here itself, I would like to conclude few more things, that is called multiplication property, right? Because some other things are there to understand. But before that, I would like to conclude by doing the matrix multiplication. If a matrix even in inner matrix kuda vandu multiply pandringa appadina, one thing you all have to keep it in your mind: matrix multiplication, right? So in order to do the matrix multiplication, I hope already you have seen it, right? Where in state space only, right? Yeah. Anyway, understanding these things in mathematics is very important. I told you I will revise all these things in engineering mathematics. It is the right time to do that one. Let's start and see the properties of matrix multiplication. Just put it. The topic is properties of matrix multiplication, right? Matrix multiplication, right? So multiplication, right? Yeah. In matrix multiplication, actually what is the procedure to apply? That is to multiply two matrix. The thing is, if I have a matrix A, right? And they said this matrix A is given as, let us do, it's given as 1, 2, 3, 4, right? Guys, wait a minute. I don't want to go to this one, right? Let me generalize. For example, there is a matrix and its order is given as n cross m, right? And there is one more matrix they are defining, that is given as, yeah, 1 second, that is given as m cross p. Now the question is, right? The question is, find out the matrix product A into B. Order of the AB is what? இதோட ஆர்டர் வந்து என்னன்னு கேட்பாங்க. That is very simple. First thing, you have to check whether these two matrices can be multiplicable or not. இத எடுத்து உங்களால மல்டிபிள் பண்ண முடியுமா முடியாதான்றதை நீங்க செக் பண்ணி பார்க்கணும். For that, you will have to check matrix multiplication could be possible whenever. இப்போ இங்க யார் கூட மல்டிபிள் பண்ண போறீங்க? Matrix A is going to be multiplied with the matrix B. So first observe the position number 1. Position number 1 ல first என்ன matrix இருக்குன்னு பாருங்க, right? So position number 1 ல இருக்க matrix ஓட column, right? The column in the position number 1 matrix and position number 2 ல இருக்க matrix ஓட row, right? If these two people are equal, then matrix multiplication could be possible. It is possible. Otherwise, you cannot do matrix multiplication. Matrix multiplication could be possible whenever, right? In position number 1, you will have to observe the number of columns. In position number 2, you will have to observe the number of rows. If these two people are equal, then I can do the matrix multiplication. And in resultant, what happens? Let me cross check. Yes, sir. Let me write that is row into column, right? Let me call it as R1 C1. This is R2 into C2. So here, matrix multiplication could be possible whenever C1 equal to R2. In the condition satisfied, I can do the matrix multiplication. நீங்க matrix multiplication முடிச்சதுக்கு அப்புறம் resultant order will become, it will be the order R1 into C2. Resultant order of the matrix is going to be R1 into C2. Clear? I hope things are clear to you all. Now take this one. Give an example. Can you do the matrix multiplication for this given function? I have to check. Check பண்ணிடலாமா? See, number of columns in the first matrix is m. Number of rows in the second matrix is m. இது அப்படியே எழுதுங்க. That is row into column. This is row into column only. Such that, see there, C1 equal to m, R2 also equal to m. So C1 and R2 both are equal. I can do matrix multiplication, and the resultant order of the matrix is going to be what? R1 into C2. R1 into C2. R1 is n into C2 is p. That is the order of the matrix. I hope things are clear to you all. This is the order of the matrix. Okay. I hope you all have understand these things, right? So in order to multiply the matrix, that's very important, right? You have to understand that things. Now let us understand few more things. The few more thing is, question என்ன கேட்பாங்க அப்படினா, identify the number of times that you are doing multiplication and the number of times that you are doing addition in a selected two matrix. அப்படினா meaning என்ன? For an example, right? Let us talk about second person. The thing is, I will have a matrix like this: 1, 2, 1, 3. This is matrix A. Similarly, let us consider one more matrix. Let me consider 1, 3, 2, 1. Let us consider matrix A and matrix B. Now we are going to multiply these two matrices during this operation, right? இப்போ இந்த ரெண்டு matrix வந்து நீங்க மல்டிபிள் பண்ணும்போது, the question is, how many times you are doing inner multiplication? How many times you are doing inner addition? That is the question. Inner multiplication and inner addition. பார்க்கலாமா? Yes. Let us see. I will write the answer clearly step by step for your better understanding. First நீங்க என்ன பண்ணுவீங்க? You are selecting the first row in order to multiply them. First row with the second column. Do you agree with me? Yes. We are doing the multiplication with there is first row with the second column. Sorry, first column. அப்ப என்ன பண்ணுவீங்க? First value with the first value we are doing multiplication. Do you agree? Yes. One multiplication and then plus one addition into second value into second value, second multiplication. Correct? Yes. So up in the first variable நம்ம எத்தனை multiplication? 2 multiplication, 1 addition we have done. Repeat. second up என்ன வரும் 1 into 3 1 multiplication exactly and then plus 2 into 1 yes. So here also I have done 2 multiplication 1 addition. Repeat. Third 1 into 1 yes plus 3 into 2 exactly. Fourth one 1 into 3 plus 3 into 1 exactly. So that is going to be a complete matrix. Now if you notice these things, right? If I am solidina, see, let me rub this one, right? In this matrix multiplication, actually here I am considering 2 cross 2 matrix. Here also we are considering 2 cross 2 matrix. Let us name like this. If I am solidina, you can name it. That is going to be m cross n. Let me call n cross p. Right? Just we are calling like this. In order to do matrix multiplication, number of columns in the matrix 1, number of rows in the second matrix 2 has to be equal, and the resultant matrix will going to be the order of, right? Rows in the first one, columns in the second one. That is the resultant matrix order. Yeah, everything is perfect. Now the conclusion is, how many multiplication that you have done in order to multiply, in order to bring out the final answer for AB? That is the question. எத்தனை multiplication பண்ணிருக்கீங்க பாருங்க? 1 2 3 4 5 6 7 8. Totally I have done 8 multiplication, right? Now let me write number of addition. You have done addition number 1, addition number 2, addition number 3, addition number 4. I have done 4 addition. இப்போ நான் ஒரு இது எழுதுறேன், அது கரெக்ட்டா செக் பண்ணிக்கலாம். இப்போ நான் என்ன சொல்றேன்னா here இத நான் இப்படி எழுதுறேன் m into n into p. செகண்ட் ஸ்டேட்மென்ட் நான் என்ன எழுதுறேன் அப்படினா m into n minus 1 into p அப்படி எழுதுறேன். இது கரெக்ட்டா இருக்கான்னு செக் பண்ணி பார்த்தலாமா? Yes. Now here I said this is called m, this is n, this is p, right? இப்போ இங்க m ஓட வேல்யூ எவ்வளோ? In our case m is equal to 2, n is equal to 2, p also equal to 2 only. இத அப்படியே இங்க சப்ஸ்டிட்யூட் பண்ணி பார்க்கலாமா? m into n into p is equal to m into n into p is equal to 2 cross 2 cross 2 will become 8 only. Similarly, m into n minus 1 into p, that it should be equal to m value is 2 into n minus 1, 2 minus 1 will be 1 into p is equal to 2, such that its answer is going to be 4. Is it correct or not? Exactly. So the generalized form. So the conclusion is, okay, let me write this one. So finalized, the answer is, let me rub this one, right? Let us rub this one. So the answer is number of matrix multiplication, right, for any system, right? Multiplication, right? So let me write, right, number of multiplicative, or you can write like this, right? Number of multiplicative should become equal to m into n into p, whereas number of addition, generalized, right? I am generalizing this is number of addition should be equal to m into n minus 1 into p. Do you agree with me? Yes. Let me take some example, because in the examination they won't give you these things, right? They will give you some big matrix, right? But you don't need to observe the matrix values at all. You can simply observe the order of the matrix. That's enough, right? So let us take one more example. Let me take some 3 cross 3 matrix for understanding. Now the given it is, we can take some general matrix. The matrix is given us, right? They said like this, 6 cross 5. They are given some matrix like this, and they are given one more matrix that is going to be 5 cross 4. Now the question is, you are requested to find out the number of multiplicative and additives, right? Additive terms while performing the matrix multiplication AB. First check whether the matrix multiplication could be possible or not. Yes, it is possible. Why? Number of columns in the first matrix, number of rows in the second matrix are equal. Exactly. So I can do matrix multiplication. Yes, that would be possible. The second thing is, in order to obtain the number of multiplicative term, I told you, right? Just to consider this is m, right? This is n and n cross p. Just to consider like this, or you can mind training வச்சுக்கலாம். See there. நீங்க first என்ன பண்ணோம்? இவங்க மூணு பேரையும் மல்டிப்ளை பண்ணோம். 6 n ஓட வேல்யூ எவ்வளோ? 5 into 4. இது number of multiplicative. Additional என்ன வரும்? 6 into நடுவுல வருது இல்லையா இந்த இன்டர்மீட். either you can select this one or this one. அதை எடுத்துட்டு அது 1 ஆல செப்பரேட் பண்ணிடணும், because n minus 1. So 5 minus 1 போட்டீங்கன்னா 4 into here also we have 4, such that the first answer is going to be 5 times of 4 will be 20. 20 times of 6 will be 120, right? Second time 4 times of 4 will be 16, right? So 16 போட்டீங்கன்னா will be 96, right? So 16 times of 6 will be 96. Am I correct? 16 and 10 times of 60 and 6 36. Yes, that is 96 only, right? So the conclusion is what? For your question, the answer is right. Number of multiplicative, right? So multiplicative should be equal to 120 and the number of addition simply equal to 96. That is how simply we are getting the answer. But you know one thing, you will be tested for this worthless question with 2 marks. Is it worth for 2 mark? If you remember these things, it won't worth for even 1 mark. Clear? Just to remember the property. These are the properties of your matrix multiplication. Apart from that, some other things are there. Your matrix multiplication, right? Matrix multiplication in the sense A into B may or may not be equal to B into A. Right? So matrix multiplication may or may not be satisfies the property of commutative. We cannot give assurity for that. But it will satisfy the property of associative. Associative in the sense, right? What we can do, A plus B plus C, right? You can do like this, right? See, wait, we are looking for multiplication, right? Let me write A into B into C should be equal to A into B and then you can multiply it by C. It will satisfy the property of associative, but it won't satisfy the property of commutative. It does not mean that always it won't satisfy. It may or may not be. You will have to cross check. Commutative property கண்டிப்பா satisfy ஆகும் நான் சொல்ல முடியாது. It depends on the matrix that we are choosing. You will have to check. செக் பண்ணி பார்த்துட்டு மே ஆர் மே நாட் டிட்டர்மைன் பை கான்ஸ்டன்ட் சரி. நீங்க சும்மா செக் பண்ணி பாருங்க. நீங்க ரெண்டு மேட்ரிக்ஸ் எடுத்துக்கோங்க. சும்மா மல்டிப்ளை பண்ணி பாருங்க. Because now I told you many proofs I had given. In the same way select some two matrix and just multiply them. You will come to know within some 30 or 40 seconds you will realize these things. Okay. So these are the properties of your matrix multiplication. I hope things are very clear to you all. Right. Now our next target is how to find out the what I told you. So till now we had kept our concentration with the determinant of the matrix. So immediately our next task we should keep our concentration with the rank of the matrix, right? Now what do we mean by rank of the matrix, right? So let's see. So we are getting close to 10 now. Yes. So let me do one thing. Let's start with this, right? Because I have to complete total things. Inverse it may take more than 1 hour for me, right? I don't want to starting right? So let's wind up the class with this, right? I hope things are very clear to all in mathematics, right? Maths is very easy, trust me, right? Slowly watch the notes as well as side line practice some problems, okay? I will also give some questions, okay? Let's wind up with this. If you have any other doubts, please you can ask in the group, right? Thank you all.